In this section, we're going to step away from Vue for a moment. If you're interested in creating small widgets for your site, you've learned everything you need to know. Loading Vue with script tags will suffice for small widget projects. However, if you're looking to build full scalable web applications, there's still much more to learn. It's possible to make apps by loading Vue through a script tag, but it's not the most efficient way. You will want to use the proper tools to help you with debugging and scaling the application. That's where we're headed next. The development team for Vue has curated a set of tools for building Vue applications. These tools are built on top of other tools. They'll help us face challenges such as optimizing bundles, code splitting, and managing assets. In this section, I want to discuss the tools Vue uses under the hood to make our lives easier. While it's not completely necessary to know the underlying tools, it may help you in future projects. A lot of job postings require that you have some basic understanding of the tools. You don't have to be a pro. The fundamentals of each tool are enough to get you started. Keep in mind that Vue takes care of many more technical and challenging parts for you. The goal of Vue is to simplify the development experience. You don't need to stress over every detail. Here are the following tools we will be reviewing in this section: Vite, Webpack, Babel, PostCSS, Sass, and ESLint. These are the primary libraries we'll be dealing with in most advanced projects. I want to stress that if you're already familiar with these tools, you may skip this section. I'm not going to be teaching anything groundbreaking or new about these tools. My main goal is to give an overview of what these tools are and how to use them. We won't be able to dive deep into these tools, as it would take up too much time. Before you proceed with this section, there are a couple of things you should know. You should have some knowledge of ES6, things like arrow functions, constants, modules, etc. We will be using modern JavaScript to build our applications. If you're ready, I'll see you in the next one. In this lecture, we are going to get started with Vite. Vite is going to bring everything together. It's one of the newest packages to enter the JavaScript ecosystem. Despite that, it's already gained a considerable following. Hundreds of thousands of developers are integrating Vite into their workflow. So, what is Vite? Vite is a module bundler for applications. During the development process of your app, you're going to be creating dozens of files. They can range from JavaScript files to images. Once you're ready to push an app into production, you may want to optimize, compress, and minify your codebase. For example, let's say you had 20 JavaScript files in a project. As we know, it's considered good practice to split your code into separate files for manageability, but the user shouldn't be forced to download dozens of files. Ideally, they should download as few files as possible. That's what Vite is for. It'll compact your project into as few files as possible. However, it can do so much more. Vite is not the only tool that accomplishes this task. If you do your research, you may come across other module bundlers such as Webpack, Parcel, Snowpack, or Rollup. Currently, Webpack is considered the industry standard. So, why are we going to use Vite? Performance is highly critical for development. Webpack is starting to show its age. As your project grows, bundling a project can take longer. Makes sense, right? Bundling hundreds of files can take a while. Unfortunately, most tools struggle with bundling large projects. Vite does not have this problem. You can always expect a project to bundle within seconds. Another advantage of Vite is its immense support for third-party libraries. A lot of bundling tools focus on JavaScript. Support for images, CSS, or other file types requires plugins. It's up to developers to add support for different types of files. Out of the box, Vite supports the most popular tools for front-end development, from TypeScript to Sass. This feature allows developers to focus on their projects rather than configuring a set of tools. This leads me to my next point. You may need a specific tool to be supported in your project. If Vite does not support it out of the box, that's perfectly fine. Vite is easily extendable. You can add support for other tools by updating the default configuration. In my opinion, configuring Vite is easier than configuring other tools. For these reasons, Vite is gaining traction among the community. It wouldn't surprise me if it became an industry standard within the next few years. Best of all, the creator of Vite is the creator of Vue. Both packages are easy to integrate together. Let's try creating a project with Vite. This process is straightforward. It's not recommended to create a project from scratch. Instead, the Vite package has a tool for quickly scaffolding a project. In your editor, open the command line. I highly recommend pointing your editor in an empty directory. We do not want the files generated by Vite to conflict with existing files. Inside the command line, type the following command: npm create vite at latest. The npm create command will initialize a package's executable. After this command, we must provide the name of the package. In this case, we're trying to run the Vite package. Let's run the command. After doing so, npm may ask us to confirm our decision to run this command. It can be dangerous to execute a package straight away. We can safely run this package. Let's proceed with the installation. Up next, Vite will ask us a few questions about our project. Firstly, it'll ask us for the project name. You can freely change the name. For our example, let's stick with the default name. After setting a name, we can select a framework. Vite is compatible with most JavaScript frameworks. It's not a tool exclusive to Vue. Even though we're learning Vue, we're not going to select it from the list. Instead, let's stick with the vanilla option. The reason is simple. The main objective of this section is to focus on Vite, not Vue. After we have a good understanding of Vite, we'll look into integrating both packages. The vanilla option will create a project with plain JavaScript. No frameworks will be installed. We have the option of using TypeScript. However, I think plain JavaScript works best. After selecting our options, a new directory has been created with the same name as our project. In addition, the Vite package will provide a list of additional commands to run. Let's move into the directory with the cd command. Next, let's install the packages with the npm install command. This process may take a while. Once the packages are finished installing, let's talk about the files and directories in the next lecture. I'll see you there. In this lecture, we are going to explore the project scaffolded by the Vite package. Before getting started, you should point your editor to the directory created by the package. It'll be easier to inspect and run commands from this directory. Pause the video if you need. Once you've got that sorted, let's begin. In the root directory of the project, there are a few files. The most important file is the index.html file. This file is considered the entry point of our application. What is an entry point? The entry point refers to the file responsible for launching an application. The entry file can import other files from images to JavaScript files. This step is important to highlight. If the entry file does not import other files, it's possible that they may not get bundled with our project. If we look closely at the HTML file, two files are being imported. They're the favicon and script files. However, our CSS file is nowhere in sight. In the project, a basic CSS file was created. Despite not being imported from the main HTML file, it will get bundled with our project. To find out why, open the main.js file. The very first line of code in this file is an import statement for the CSS file. Typically, import statements for CSS files are not supported. The JavaScript language does not allow this behavior. By using Vite, CSS imports are allowed from within a JavaScript file. During the bundle phase, the CSS will be extracted into a separate file. The CSS will not be embedded into our script file. We do not need to worry about bloat. Not all dependencies need to be imported into the entry file. Since the script file is imported into the HTML file, our script is allowed to import additional files. There isn't a limit as to how many files can be imported. Let's try running our project. Open the package file. Overall, the package is very simple. There's nothing abnormal about it other than the script's object. From the beginning, We're given 3 commands for running our project. The first command is called dev. This command will launch a server for development. You may not want to constantly manually build your project. The dev command will force the server to watch your files for changes. If a file changes, the build will reflect those changes. The process is completely automated. Let's give it a try. Open the command line. I recommend moving the command line into a separate tab. I find it easier to read the command line as a tab as opposed to a separate panel. You can drag and drop the terminal by its name. After moving the terminal, let's run the npm run dev command. After a few moments, the package will create a temporary server for viewing our application. Let's visit this URL in our browsers. Voila! We've got a fully functional development environment. We can start working on our project. As we do so, the package will refresh the page during updates. Let's head back to the command line to explore the other commands. The next command in the package file is called build. Unlike the dev command, the build command will build our project once. If we look in our projects directory, nothing has changed. What if we want to grab the final bundle? The build command will output the files for us. Let's give it a try. Back in the command line, you may need to exit the current command. By launching the server, Vite does not allow us to run additional commands. In the command line, run the npm run build command. In a few moments, the command will produce a bundle in a directory called distribution. We can check out this folder for the final output. These files can be uploaded to a server for production. You do not need to include files outside of this directory. As I mentioned before, only files imported directly or indirectly from the entry point file will be included. In the assets directory, we will find the CSS file. What if we removed the import statement for this file? Let's find out. In the main.js file, remove the import statement. Next, run the npm run build command. If we look at the distribution/assets directory, the CSS file is missing. Since our app is not importing CSS, this file is not included with the bundle. Before uploading our project to production, we may want to verify that the app is fully functional. However, we can't because the server is not running. In the command line, we can run the npm run preview command to launch the server for the distribution directory. The preview and dev commands are similar. There's one huge difference. The preview command does not watch our files for changes. The purpose of the preview command is to launch a server for the build directory. It allows us to quickly inspect the final build. The dev command is for the development phase of a project. Now that we have an overview of our project, let's start exploring some of the features of other tools. Along the way, we'll learn more about Vite. When you're ready, I'll see you in the following lecture. In this lecture, we are going to start exploring a second tool called Sass. This lecture will be a brief overview of the language. Sass is a topic that deserves a course of its own. I encourage you to look at other courses or tutorials to learn more about Sass. In the resource section of this lecture, I provide a link to the official site for Sass. Sass is a programming language for CSS. CSS is not known for being an intelligent language. Features like functions or conditional statements are non-existent in CSS. Sass was introduced for extending CSS. We can perform various actions, from defining functions to looping through an array of data. Sass is an extremely powerful language. However, Sass is not supported in the browser. It must be compiled into CSS. Luckily, there's a package for handling this process. In your editor, open the command line. Let's install the Sass package with the following command: npm install Sass. Out of the box, Vite supports Sass. We do not need to configure Sass. This means we can start writing Sass right away. In the previous lecture, we removed the import statement for our CSS file. Rather than importing a CSS file, let's import a Sass file. In the project, rename the style.css file by changing its extension to scss. The extension for writing Sass is scss. Next, let's open the main.js file. At the top of the file, import the main.scss file. Next, let's launch the server. In the command line, run the npm run dev command. For the rest of this section, you should always have this command running. Let's check out the app in the browser. As you can see, the styles are being applied to our elements. Otherwise, the text would not be centered. Vite was able to import the Sass file, compile it, and include it with the bundle. We can prove this behavior by opening the Elements panel with the developer tools. Search for a style tag in the head section of the document. If you know CSS, you already know Sass. Sass supports all CSS features from selectors to variables. It does not attempt to override the language. It simply extends it. Head back to the editor. In the Sass file, let's start exploring some of the cool features that Sass has to offer. The first feature is functions. It's common to apply color effects to an element during an event. For example, if a visitor hovers their mouse over an element, the color might change. Let's give that a try. Add an H1 selector. Set the color property to the following value, #cc3244. Next, add another selector called H1 hover. The value for the color property will be a function called darken. The darken function is not available in CSS. It's defined by the Sass language. This function will return a new color with a darker shade. Functions are written similarly to JavaScript functions. It's the name followed by a pair of parentheses. It has two arguments, which are the color and the percentage. Let's pass in the same color as before, which was #cc3244. The second argument is a percentage value. The higher the value, the darker the color. Typically, I like to use any value between 5 and 15%. Let's use 15%. Switch over to the browser. You shouldn't have to refresh the page. Vite will automatically reload the page for you during updates. If we look at the heading, the color is red. We can hover our mouse over the color to view the new color. As you can see, we do not need to calculate a darker color ourselves. Sass is capable of picking a color for us. In the resource section of this lecture, I provide a link to the list of functions you can use to change colors. Admittedly, the official documentation isn't that easy to read or navigate. I encourage you to take your time with it and experiment with some of them. Alright, let's continue exploring other features. Another cool feature of Sass is nesting. Head back to the editor. Switch over to the main.js file. Let's wrap the word Vite with a pair of span tags. It's not uncommon to style nested elements. Back in the CSS file, we can change the color of the span element by creating a selector called H1 span. With Sass, we can take a different approach. Instead of typing this selector, we can add the span selector from within the H1 selector. Nested selectors are allowed. During compilation, the selector will be transformed into H1 span. Initially, this syntax may look weird, but there are two benefits to this feature. Firstly, the precedence in CSS becomes clearer. When your code is formatted like this, it can be easier to see which CSS properties will dominate others. The second benefit is that you won't end up repeating the same selectors since it's easier to tell where you've written them. Inside the span tag, change the color property to blue. In some cases, you may need to reference the parent selector. A perfect example of this scenario would be the hover pseudo-selector. We could nest this selector inside the H1 selector like so. However, this solution won't completely work. This selector will produce a weird selector. It would be transformed into H1 hover. We don't want this. We want the same selector we had before. SAS provides a selector called the ampersand selector. Replace the H1 selector with the ampersand symbol. The ampersand symbol will represent the parent selector. SAS will replace this symbol with the parent selector. This will result in the selector being H1:hover. Let's try testing our code by switching to the browser. The span tag content will be the color blue. We can hover over this element to change the color to a darker color. Great! We've successfully learned another feature of SAS. SAS is a great language. It's definitely worth learning. I encourage you to play around with it and see what you can do. A single lecture doesn't do it justice, but it should suffice for now. Before I end things, I want to say that you don't have to be a master of SAS. We won't be using it heavily in this course. Just because Vite supports a tool doesn't mean you're forced to use it. We'll be focusing mostly on Vue, but it's always good to know what SAS is and how it works. In this lecture, we are going to move on to another package called PostCSS. SAS is a dominant language in the development world for extending CSS. As the years go by, it's starting to lose popularity. Another package was introduced called PostCSS. It takes an entirely different approach from SAS. You can use PostCSS over SAS, or a combination of both. Before getting into PostCSS, let's talk about how SAS works. SAS is a preprocessor language because it's a language that gets compiled into CSS. It's because browsers don't understand SAS code. There are dozens of preprocessor languages available, like Less or Stylus. In the end, they all get compiled to CSS. PostCSS takes a different approach. It is not a language. There is no special file extension. Instead, it's a library written in JavaScript. It'll convert your CSS into an object. The object it generates can be manipulated and transformed with JavaScript. Once you've made your changes, the object will be compiled into CSS. The advantage here is that we can use JavaScript to interact with our CSS code. This is why it's called PostCSS. It is a library that can modify your CSS code after you've written it. PostCSS is popular within the Vite and Vue community. Unlike SAS, we do not need to install the PostCSS package, nor do we need to configure this package. It's installed and configured by Vite. This feature gets activated by creating a specific file in our project. In the root directory of our project, create a file called postcss.config.js. PostCSS will search for this file. If it finds this file, it'll load the configuration settings. Inside this file, we must export an object. The object will contain our configuration settings. There are several things we can do, but we'll keep it simple. By default, PostCSS does not apply changes to your CSS. You must install plugins for manipulating the output of your CSS. There are two options at our disposal. Firstly, we can install plugins from third-party developers. Secondly, we can develop custom plugins. For this demonstration, we are going to use a third-party plugin. Vendor prefixes are an important feature of CSS. They allow us to use experimental features in our CSS. However, we may forget to use a vendor prefix. There's a plugin for automatically applying vendor prefixes to your CSS code. There's a vast repository of plugins available. In the resource section of this lecture, I provide a link to a site called PostCSS Parts. This site provides a list of plugins from the community. I highly recommend bookmarking it if you plan on using PostCSS in future projects. Let's switch back to the editor. Inside the command line, input the following command: npm install autoprefixer save-dev. This module is a plugin for PostCSS. It'll scan our CSS properties for missing vendors. It'll add vendor prefixes to properties that require a vendor prefix for older browsers. After installing this plugin, we must load it from within the configuration file. In the configuration file for PostCSS, we'll add a property called plugins. Its value will be an array. Inside this array, we can load a plugin by calling the require function. This function accepts the name of the package to load. Let's pass in autoprefixer. Great! The plugin should get loaded into our workflow. To test our code, let's update our CSS. Open the style.scss code. PostCSS does not work with Sass. Luckily, Vite will process Sass first. After the Sass file has been compiled into CSS, the CSS will be passed on to PostCSS. It's perfectly fine to continue using Sass. Alternatively, you can switch back to CSS and remove Sass from your workflow. Either option is at your disposal. Inside this file, let's add a selector called : placeholder. Next, change the color property to red. The placeholder selector will allow us to manipulate the properties of an input's placeholder. Developers will add this selector to change the color of the element. This selector has a prefix for Firefox. What if we forget to add the prefix for this browser? No problem. The autoprefixer plugin will add it for us. Let's save our file. Next, we may need to restart the server. Otherwise, the plugin may not be applied to our project. In the command line, restart the npm run dev command. So far, we shouldn't receive errors. Let's view the application in the browser. Nothing has changed. In the developer tools, open the Elements panel. Search for the style tag in the head section of the document. The placeholder selector was duplicated. The second copy of this selector has the Mozilla prefixer applied to it. That's great. We never have to worry about forgetting to add a prefix to our CSS. In addition, we can purposely leave out prefixes from the original codebase. It'll keep our code clean. PostCSS can handle adding the prefixes during compilation. That's all there is to PostCSS. It's a tool you can configure with plugins to transform the output of your CSS. In this lecture, we are going to explore a tool called ESLint. Code quality is an important part of development. We should always be consistent and error-free. JavaScript is a great language, but it does not enforce strict rules for formatting our code. For example, open the main.js file. Inside this file, we're using single quotes. Let's say our team wants to use double quotes. From time to time, we may forget to use double quotes in a file. It's not uncommon for developers to be inconsistent with their formatting. JavaScript will not complain. As far as JavaScript is concerned, everything in the file is valid. This is where ESLint joins the picture. It'll enforce stricter standards in our code. We can create a set of rules to apply to our code base. If we break a rule, we'll be informed by ESLint. We can catch problems that normally won't be caught by an environment. Let's give it a try. In the resource section of this lecture, I provide a link to the official site for ESLint. On this page, we're given an example of a command for installing ESLint into our project. Let's copy this command to our clipboard. Next, switch over to the command line. Paste and run the command. Vite does not provide support for ESLint. This is one of the instances where a package is not automatically installed or configured for a project. We must manually integrate ESLint into our workflow. Luckily, it's really easy. Vite is easy to extend. In the command line, run the following command: npm install Vite plugin eslint save dev. This package will instruct Vite to run our JavaScript code through ESLint for code quality. While not necessary, it'll be easier to use this plugin. Next, in the root directory of the project, create a file called vite.config.js. This file can contain the configuration settings for Vite. The name is very important. Otherwise, Vite will ignore our settings. Creating this file is optional. If this file does not exist, Vite will stick to its original configuration. In our case, we're trying to add support for ESLint, which is not part of the default configuration. In this file, we must export an object. Inside this object, we can add a list of settings. While exporting an object is not a bad thing, there's an easier way to configure Vite. I'm going to add a property called plugins. As I do so, I don't receive help from the editor for correctly spelling this property. What if I make a typo? It does happen from time to time. We should try our best to avoid wasting time. Vite has a function for helping us with code completion. At the top of the file, import a function called defineConfig from the Vite package. Next, we can wrap the object with this function. This function will return the object passed into it. Seems redundant, but it does offer code completion. Let's try typing the plugins property again. This time, the editor will be more helpful with the property name. It'll offer to complete the line of code for us. It's a simple workaround, but you can never be too careful. I prefer to use this function to avoid errors. Let's set this property to an array. In this array, we can start adding plugins from other packages. Before uploading this array, we must import the ESLint package. At the top of the file, import the ESLint function from the Vite plugin ESLint package. Next, call the ESLint function from within the array. That's all there is to it. ESLint will check our code during development. Let's switch over to the command line. In the command line, start the server with the npm run dev command. The command line is going to throw an error. This is to be expected. We installed ESLint, but we haven't configured it. ESLint will search for a configuration file from within our project's directory. In the next lecture, let's work on configuring ESLint with our project. In this lecture, we are going to configure ESLint with our project. We took the first step by installing ESLint. The next step is to configure ESLint directly. Keep in mind, ESLint is a separate package from Vite. This package requires a separate file for configuration. There are various ways to configure ESLint. We can add the settings directly to the package file. Alternatively, we can create a separate file. I prefer to create a separate file. This reduces clutter in the package file. It'll be easier to focus on ESLint by using a separate file. In our project's root directory, create a file called .eslint.rc. Inside this file, we'll input an empty object. This object should contain your settings. In this object, add another object called rules. In the resource section of this lecture, I provide a link to an official list of rules in ESLint. We have the option of picking and choosing which rules should apply to our codebase. We're not forced to use everything at once. ESLint does a great job of providing a description for each rule. If you need more info, you can click on a rule for code examples. For this demonstration, we are going to enable a rule for enforcing double quotes. Head back to the editor. In the rules object, add a property called quotes. This rule will enforce double quotes. The value for this property can be one of three values. We can set this rule to off to prevent the rule from being applied to our codebase. This is the default value for most rules. The second possible value is warn. ESLint can cause our project not to be built. The warn value will allow errors to go through, but will display the problem in the console. The last possible value is error. Unlike the warn value, the error value will not allow our project to be built. We must address the issues thrown by ESLint before building our project. Let's set this rule to error. The rule is ready. However, we're not finished yet. Below the rules object, add an object called environment. There are dozens of environments JavaScript can run in. ESLint doesn't assume which environment our code will run in. We can specify the environment through this object. In our case, our app runs in the browser. This property will be set to an object of environment we can turn on or off. Add the browser environment and set it to true. By enabling this environment, ESLint will not throw errors related to the browser. Next, add an object called parser options. In our script, we're using import statements. We must add explicit support for ES6 import statements by configuring the parser. In this object, add a property called ECMA version. This property's value should be the version of JavaScript. Set the version to 2022. Next, add the source type property. This property's value should be set to module to support import statements. Our configuration is ready. The next step is to start the server. If you have it running, you will need to start it. The configuration settings will not take effect until the server has been restarted. In the command line, run the npm run dev command. After a few moments, an error will get produced by Vite. The error stems from the code quality check by ESLint. As you can see, the error informs us of the file name and line numbers. In addition, a description is given for each error. In the main.js file, we have strings created with single quotes. Let's open this file. While it's great that ESLint caught these errors, we have one problem with the presentation of the errors. We must constantly switch to the console to check for errors. It would be great if the editor could point these errors out from the file. Fortunately, there's an extension for adding this feature. Switch over to the Extensions tab for Visual Studio Code. In the search box, search for an extension called ESLint. This extension is managed by Microsoft. Let's install this extension. You may need to restart your editor after installation. I'm going to quickly do so. After enabling this extension, red lines will appear under our code. We can hover our mouse over these errors to inspect them. As you can see, we can read errors directly from the file. We do not need to switch to the console to discover errors. That's great. The question becomes, how can we fix this error? There are two options. Firstly, we can manually fix these problems. But what if we had dozens of errors? It would be a nightmare to fix our issues. The second solution is to allow ESLint to fix our errors. Open the package file. Under the scripts object, add a new command called lint with the following value: ESLint main.js fix. The ESLint command is available from the ESLint package. This package will perform the linting process. If you want to use ESLint without tying it to a specific tool, you can use this command. After this command, we must specify a file to lint. Lastly, we're chaining a flag called fix. By default, ESLint will only output errors. However, we can force ESLint to fix any errors found by it. Fixing errors is not always guaranteed. If it fails to fix an error, you may need to manually fix the error. Let's try running the command. In the command line, run the npm run lint command. After a few moments, the file should have been updated. If you switch to the main.js file, the errors have gone away. ESLint swapped the single quotes with double quotes. Awesome! We've successfully fixed the problems with our file. Technically, single quotes do not produce errors, but we are enforcing a standard in our project. Overall, ESLint is a powerful tool for checking the quality of our code. We've only scratched the surface. As we dive into Vue, it'll help us catch basic problems, such as unused variables or import statements. Let's continue exploring tools in the next lecture. In this lecture, we are going to get a brief overview of Webpack. Throughout this section, we've dedicated our time to learning about Vite. Vite is going to be our primary choice of a module bundler. However, you may encounter Webpack during your career as a developer. This lecture will give a quick overview of what Webpack is and how it works. In the resource section of this lecture, I provide a zip file. Download this file, unzip the contents, and point your editor to the directory with the files. I recommend uploading these files to an empty directory. Pause the video if you need. Once you're ready, let's try installing the dependencies. Open the command line. Let's run the npm install command. While the packages are being installed, let's explore the files. The script and CSS files are copies of the files from the Vite project. The project I've provided will output the same behavior as the previous project. However, these files are bundled with Webpack instead of Vite. Let's open the webpack.config.js file. Unlike the Vite configuration file, there are dozens of lines of code. Webpack is more hands-on than Vite. As far as Webpack is concerned, only JavaScript code is supported. Support for other languages like CSS or Sass is not supported. Every tool must be configured in the bundling process. For this reason, Webpack has a higher learning curve. To save time, I've provided the configuration code for you. Let's review it together. During the bundling process, Webpack will search for this file. If this file exists in our project, it'll apply the settings exported by the file. There are 4 properties that can be configured. The first property is the entry point. Previously, Vite configured the entry point as the HTML file. For Webpack, we must set the entry point to a JavaScript file. The entry property allows us to specify the entry point of our application. In this example, we're passing in a relative path to the index.js file. Up next, we have a property called output. In addition to setting the entry point, we must tell Webpack where to save the bundle. In this object, there are 2 properties called path and file name. The path property should point to the directory. The value must be a full system path. To help us generate a full path, we're using a constant called directory name to point to the current project directory. This constant is defined by node. Afterward, we're appending a relative directory called distribution. This directory doesn't exist, but that's okay. Webpack will create it for us during the building process. As for the file name property, we can set the name of the file produced by Webpack. In this example, we're setting the name to bundle.js. Let's move on to the modules.rules property. As I mentioned before, Webpack supports JavaScript. Other languages or file types are not supported. We must add explicit support for other types of files. Loaders are packages that will help us support different files. In this example, we're adding support for 2 types of files, JavaScript and CSS. Each object in this array can represent a file type. In the first object, we're adding support for JavaScript. Hold on a moment. Didn't I say Webpack supported JavaScript? Well, that's true. The support may be lackluster. New versions of JavaScript are released annually. You may want to start using newer features from the language. However, these features may not be available in the browser. There's a package called Babel. This package adds support for new and experimental features in JavaScript. Oftentimes, developers will integrate Babel with Webpack. This is why I've included this object. This object has three properties. The first property is called test. Before a file is given to a tool, Webpack will test the file name against this property. Babel does not process CSS or image files. To avoid Babel from processing the wrong file, we can test the file name. The value for this property is a regular expression. It'll check the name for a JS extension. If this extension exists on the file, Babel will process the code. Up next, we have a property called exclude. It's not uncommon to import code from packages in the Node Modules directory into our project. There are thousands of files within this directory. To speed up the bundling process, we'll skip files in this directory. They should already be optimized for the browser or Node. Lastly, we have a property called use. This property can be set to the name of the package that contains a loader for processing a file. In this case, we're using the Babel loader package to process JavaScript code. Let's scroll to the second object. The properties are going to be similar. The second object is testing for a SAS file. There is no exclude property. It's completely optional to add it in. Lastly, the use property is set to an array. We're not forced to apply a single loader. We can apply multiple loaders. In this example, we're applying loaders for SAS, CSS, and post-CSS. There is an additional loader called mini-CSS. By default, Webpack will bundle our CSS and JavaScript into a single file. However, that's not ideal. We may want to separate both languages into their respective files. The mini-CSS loader will handle extracting CSS from a JavaScript file. This loader can be configured through a plugin. Below the modules object, we have an array called plugins. Within this array, we can add plugins for extending Webpack with additional behavior. In this example, the mini-CSS package is being configured by setting the file name of the CSS file. The last setting in our file is the watch property. By default, Webpack will build your project once. However, you may want Webpack to constantly watch your files for changes. Setting the watch property to true will enable this behavior. I know I flew through the configuration. This lecture was meant to give an overview. We're not going to be using Webpack. I included this lecture for those of you who are curious as to what the hype is about for Webpack. Let's try running Webpack. In the command line, run the following command: npm run start. In a few seconds, Webpack will watch our project. We can update our code for a new bundle to be produced. The bundle will be created in the distribution directory. If we look inside this directory, we're going to find the JavaScript and CSS code. There are some things missing from the Vite project. For example, an HTML file is not available. We don't have a server for previewing a project. It is possible to generate a server, but I wanted to keep this lecture brief. For that reason, I only included support for JavaScript and CSS files. In addition, ESLint is not checking the quality of our code. Webpack can support additional tools. Feel free to add support for these features. Anyway, that about does it. In the next lecture, let's wrap things up. I'll see you there. Congrats! You've made it to the very end of this section. We've only gone over the basics of each tool and its concepts, but it should be enough for you to tackle complex Vue projects confidently. For the rest of this course, we're going to use Vite. There are other tools Vue uses internally than the ones I talked about in this section. We'll review them as they arise, but the ones I mentioned in this section are the primary tools you'll most likely be dealing with from within your project. As always, I encourage you to continue your studies in each of these tools and libraries to make you into a better Vue developer. Now that we have an overview of things, let's get back into Vue. It's time to start developing applications. I hope to see you there. It's time to scaffold a project with a package called Create Vue. It's the official tool for building, compiling, and managing Vue applications. It's completely optional, but I absolutely recommend it if you plan on building complex Vue apps. Before running this package, let's talk about it briefly. The Create Vue package is a tool manager. Its purpose is to help you organize your files, pre-configure tools, and let you start building your application right away. The code base of an application can be broken into two parts. There's the application code and code from external libraries. Code from external libraries can be considered code from libraries like Vue or Axios. It's code we didn't write, but are using in our application. Application code is the code we've written to get a functioning application. Splitting your code base into different files is ideal for development. It makes things easier to manage and track. It allows for flexibility when you need to update files. The problem with this approach is the amount of files that can be present in an application. They can be scattered across several directories. This introduces the necessity for tools like Vite, PostCSS, and Sass. Tools can help us manage an application. Best of all, we can bundle files into as few files as possible. A new problem is introduced. These tools are independent from each other with separate configuration settings. On top of developing our application, we would have to take the time to manage a tool set. They need to be configured to work alongside each other. The more tools we introduce, the more complex configuration can get. It's a lot of work just to get an app up and running. This is where the Create Vue package comes into play. This package will help you with setting up a Vue project with Vite and other tools. Sounds redundant, but it makes the process massively simpler. It'll even provide you with a basic setup if you wish. Alternatively, you can create a custom setup for future projects. By using this package, our project will be ready for development and production. If you watched the previous section, you learned how exhausting it can be to configure tools. There's a lot that needs to be done before diving into app development. It's not a pleasant experience to go through every time you want to start a new project. Vue will expedite this process by asking you a few questions about your project. Based on your answers, it'll configure the tools necessary for running a Vue project. This tool will allow you to jump straight into your project. You also have the option of adding additional features you may need as your development workflow progresses. What took an hour to set up in the previous section will only take a minute with the Create Vue package. In the resource section of this lecture, I provide a link to the official Create Vue repository. Here you'll find more information about this tool and what you can do with it. At the bottom, we're given some commands to get us started with this tool. Let's try running the CLI together. Switch over to your command line. Inside the command line, input the following command: npm init vue at latest. After the @ character, we can input the version of Vue. For example, we may want to create a project with version 2. We can input this version like so. If you're not interested in specifying the version, you can type latest for the most recent version of Vue. Before you run any commands, I recommend you place yourself in a directory exclusively for development projects. Vue will need some room to build the project when we run the command. Let's run this command. It can be dangerous to run packages. As an extra precaution, npm will ask us to verify our actions. In this case, I think it's safe to run this package. Afterward, we need to provide a project name. The name of our project will be called Components. The topic we'll be discussing in this section will be about components. The name will reflect that. Feel free to use a different name if you'd like. Up next, we're going to be asked a series of questions for specific packages. In the future, we are going to integrate several packages. For now, let's select No for everything. After selecting this option, Vue will begin creating, preparing, and configuring your project. This may take a while for some of you, just be patient. After some time has passed, Vue will tell us the project has been successfully created. From here, it'll tell us to execute a couple of commands to start the server. Let's move into the directory first. Before we start the server, let's briefly look at the files and directories. Some of these files should be familiar to you. If you know what these files do, then that's great. If not, that's fine as well. We'll review them shortly. We were able to get a starter project with a single command. It created a list of modules, configured them, and generated files for getting started. It saved us time from having to do this ourselves. From the beginning, you can see the benefits of using this package. We're free to edit any of these files. We can make changes to the current configuration at any point. We're not forced to use the default configuration settings. We'll dig deeper later, but let's try running on the server. Under the hood, the project has been configured with Vite. We have access to the same features as the previous project. This includes the server. We didn't use the server for most of this course. This is because we were dealing with 1 or 2 files. We weren't making external requests. We're going to be discussing more advanced topics. A server will be necessary because browsers impose limitations on files opened directly in the browser. To remove any limitations, we'll need to deliver the files via a server. Fortunately, we don't have to worry about the code that makes the server function. It works completely out of the box. That allows us to focus solely on the project itself. Switch over to the command line. First, we must install the packages from the package file. Packages are not installed for us. They must be manually installed. In the command line, run the npm install command. Next, type the following command, npm run dev. This is a command you can find inside the package file. This command will start a server. The server will bundle our project and serve the bundle for us. We can preview our project with this command. After a few moments, Vue will tell us that the project was successfully compiled. This is something important I want to highlight. If you can recall, there are 2 versions of Vue, one with the compiler and another without it. The one we're using in our project is the one without the compiler. Vite has been configured to compile the template during the build process. The template will be transformed into a render function. The final bundle outputted by Vite will not need to be compiled on the client. We can continue writing HTML and not worry about having to code objects for the virtual DOM. Below this log, we'll be presented links to view our application. We can click on them to open a new tab in the browser. You will see something similar to what I see. There are links we can click on to learn more about the tools that were installed. One of the main selling points of Vue is its simplicity. However, for quite some time, in order to create complex projects, you had to learn and configure various tools. Vue was designed to allow us to focus on our project. There may be times when you'll want to configure Vite differently, but we'll take a look at that later. For now, the default configuration works fine. Therefore, we'll be jumping into the project very soon. In the next lecture, we'll go a little deeper into the files scaffolded by the Create Vue package. In this lecture, we're going to briefly talk about servers. In the previous lecture, we ran a command that started a server for us. We were able to view our application in the browser by visiting a special URL. Let's examine the URL closely. Our browser is pointing to a URL called localhost followed by some random numbers. What is localhost? What do these numbers represent? Our application is being served by a server. Let's explore what that means. A server is a machine similar to our personal computers. One of the major differences between a server and our computers is that there is no GUI. We can't click on icons, buttons, or view graphics in general on servers. So what's the point of having a server? A server can have software installed on them for handling network requests. The job of a server is to listen for incoming requests. Whenever we type a URL in the address bar of a browser, The browser will initiate a request to a server. The server is responsible for responding with some data. This can be a file like an HTML, image, CSS, or JavaScript file. The job of the server is to hold a copy of our application. The main benefit is not having to maintain the server on our machines. We don't have to purchase the hardware, set up, or maintain a server. There are services available that specialize in hosting applications on servers. Up until now, our application has been working without the need for a server. We've been opening files directly in the browser. We're going to be using some advanced features of the browser. Browsers limit features if we open files directly in the browser. This includes HTML files. Here's where our problem begins. We need a server to host our application. Luckily, we won't need to write a server. Vite provides a server out of the box. It allows for developers to continue writing Vue applications without having to worry about running a server. In the address bar, our app is delivered by a URL called localhost. Localhost is a special URL we can type in the address bar. If we type localhost, the browser treats the request differently. Instead of sending the request to a server located somewhere in the world, the request will be sent to our computer. This allows our computers to handle the request. Vite will run a server on our computers that can handle the request if we type in localhost. The server will respond with the HTML, CSS, and JavaScript files we have in our project. We don't need to write a single line of code to get this functionality working. That's great because it allows us to focus on our app. The CLI adds additional features to our project that make the development experience easier. The server will watch for file changes in our project. If a file is updated, the server will refresh the browser to show the latest changes. That saves us time from having to refresh the browser ourselves. There's a whole lot of other things the CLI can do for us, which we'll learn about as the course progresses. There's one last question. What do the numbers represent? This part of the URL represents the port number. You can think of ports as doors to a house. A house can have numerous entrances. One door leads to the kitchen, another leads to the bathroom, so on and so forth. Similarly, servers have ports for accessing different parts of a server. The browser needs to know which door on the server leads to the application. Multiple applications can exist on a server. We need to assign a port for our app. By default, the CLI will assign the app to a port for us. The port can be specified in the URL by adding a colon after the domain. This character is followed by the port number. Normally, we would never have to add the port number to the URL. For example, let's change the URL to google.com. The port number is not necessary for this URL. The reason we don't need to add a port number is because most browsers will default to port 80. Most applications are configured to be delivered over port 80 on the server. Port 80 is the recommended port when shipping an app to production. So why does CLI use a different port? Only one application can be assigned to a port. You can't have multiple apps using the same port. On most personal computers, it's possible that port 80 may have been taken. Luckily, computers have thousands of unused ports. The CLI will search for an unused port. It'll reserve the port for our application. This way, we can view the app on our machines locally. That wraps it up for now. We can tell the browser to access our server by typing in localhost in the URL. We don't have to worry about the restrictions imposed by the browser because we have a server to deliver our app. In the future, we'll look at how we can upload the app to a server for production. For now, we'll be working locally. In this lecture, we're going to review the files generated by the Create Vue package. We'll start with the root files. Then, we'll move on to the directories. The very first file is the gitignore file. This file is for those who plan on using Git or GitHub. It'll instruct Git what files should be ignored when you push files into the repository. You don't want to upload every file in your project. The CLI has taken the opportunity to list files you shouldn't upload, files that shouldn't be shared with others. If you plan on using Git for this course, then this file is beneficial to keep around. For this project, we won't be using Git. Feel free to delete or ignore this file. The following file is called index.html. If you were to look inside this file, it'll be the same HTML file from the vanilla JavaScript project with minor modifications. Overall, the index file serves as the entry point to our application. It's importing the script file from a directory called source. We'll look at this file in a moment. Up next, we have the package file. There are some interesting things going on in this file. Firstly, the dependencies object contains the Vue package. Previously, we installed Vue through a CDN. This time, we're going to work with a local copy. In the development dependencies object, we have an additional package called plugin Vue for Vite. Naturally, Vue does not work with Vite. Vite does not assume which front-end framework we're using. For this reason, we are installing an additional plugin for integrating Vue with Vite. Moving forward, we have the README file. The contents of the README file has information about how to run the project, basic information to help you get up and running. There's even a link on how you can configure the project created for you. The topics covered in the documentation are things we'll go over as the course progresses. Lastly, we have the vite.config.js file. There are two noteworthy things about this file. Firstly, Vue is configured with the project by importing the Vue function. This function is called directly from the plugins array. Luckily, we don't need to dive into the inner mechanics of this plugin. All we need to know is that the plugin will help Vue understand Vue files. If we were to view the files inside the source directory, we'll find some files with the Vue extension. The Vue plugin will help Vite process these files. We'll explore what Vue files are later in this course. You may have noticed it already, but a configuration file for PostCSS is not present. It's one of the tools we discussed earlier. Despite that, the Vue plugin will configure PostCSS for us. It may not look like it, but our project CSS will be processed by PostCSS. Regardless, you may want to configure PostCSS. We are allowed to configure PostCSS by adding the PostCSS property to the package file. Vue will prioritize the settings in the package file over its own. Feel free to add it. For this project, the default configuration will work fine. The second noteworthy thing in this file is the resolve.alias property. You can think of an alias as a shortcut to a directory. Throughout this course, we're going to be importing dozens of files in nested directories. It can be tedious to write paths to files. To keep things simple, we can create an alias to a specific directory. In this configuration file, we're provided an alias called @. This alias points to the source directory. Here's an example. Let's say we had a file called example.js. There are two options for importing this file. Firstly, we can type the path to the file. Alternatively, we can replace the source directory with the character. Vite will handle replacing this character with the appropriate path. Keep in mind, the alias is only available with Vite. We can't use the alias outside of it. Using the alias is completely optional. That concludes the files in the root directory of our project. Up next, we have three directories. The Node Modules directory will contain the modules installed for this project. The public directory contains your static assets like images and HTML files. By default, the project will provide us with a favicon file. There's not much going on in this directory. Next up is the source directory, which is probably the most important directory. It will contain most of your application's logic, templates, state management, etc. We will be spending a majority of our time in this directory. Let's start with the main.js file. Inside this file, we're importing two things: the createApp function from the Vue package and an object called app. The createApp function is what will create the application as we've learned in previous sections. The Vue module can be found inside the Node Modules directory. The project is set up to automatically look for the Vue module. You don't have to worry about the path. The app module is a bit peculiar. We're not loading a plain JavaScript file. We're loading a Vue file. Vue files are considered components. They all end with the Vue extension. Upon inspecting the file, you will find a lot is going on. Before I break down what's going on, you may not have syntax highlighting for this file. If you're using Visual Studio Code, you can install a plugin called Volar. This plugin will enable syntax highlighting for Vue files. I recommend installing it if you have Visual Studio Code. If you're using a different editor, search for a plugin that will enable syntax highlighting. Let's break down what's inside a Vue file. Files that end with the Vue extension are called single file components. Single file components are made up of 3 blocks. There's the HTML, JavaScript, and CSS. The HTML is placed inside the template block, the JavaScript is placed inside the script block, and the CSS is placed inside the style block. All 3 blocks are compiled into a JavaScript object. This way, when we're importing the object in other files, it'll be usable because it's an object. The object exported will contain all 3 blocks. Let's examine what a single file component looks like after it's been compiled. Inside the command line, we'll run the command npm run dev and open the page in the browser. Next, I'm going to switch back to the app component and make a small change. I don't expect you to follow along, just watch. After making this change, I'll switch back to my browser with the developer tools opened. Inside the network panel, there will be a request that we can click on. This request will contain the changes made to the file. I'm going to copy everything inside this request and paste it into a random file. Alright, as you can see, I've stripped down what was returned by the request. I've removed most of the references to Vite. They're not needed to understand this example. This is the only part that matters to us. I know I went through a lot to get to this point, but this is the main thing I want you to focus on. Don't worry about the other stuff. This bit of code is what the template inside the app file gets compiled to. It gets turned into a render function. Inside the render function, there's a lot of confusing things going on. However, understand one thing. The value returned by the render function must be an object that represents the elements we want to render on the document. This function has been produced by Vite and the Vue plugin. The purpose of writing single file components is to make this process easier. If you had to pick between writing out your application between a render function and the single file component, then you may lean towards the single file. That's the basics of it and all you really need to know. We're going to continue using single file components as it makes our code readable and manageable. Let's go back to reviewing the files. Back inside the main script file, we're using the createApp function to initialize the app. We're passing in the app component to the createApp function. Vue will run the render function because that's what the single component file will be compiled to. The last thing going on here is the Vue application being mounted. The mount method is called to start this process. This wouldn't work without Vite. Thanks to Vite, creating components has been simplified. This has been a basic review of everything. Of course, there's way more to it, but we'll dive into other topics as the course progresses. It's time to start writing some code. When we installed the project, we were given a few starter files inside the source directory. It provides a basic example on how you would create components and structure them. That was nice and all, but I want to start from scratch. We'll clean up the project so that we can focus on the basics. We're going to delete the components and assets directories. Neither are necessary. Then inside the app component file, we're going to remove the style block. Adding CSS to a component is completely optional. If you decide not to have stylings for your component, then Vue will not throw an error. We're also going to reduce the code inside the script and template blocks. On the script block, remove the setup attribute. This attribute is a shorthand syntax for the composition API. which we won't be using in this section. Unless I state otherwise, this attribute should always be removed from the script block. The bare minimum requirements for a single component file to be valid is the template block. The template block must contain at least one root element. We're allowed to have multiple root elements in an application. Inside the template, we're going to add a simple greeting in the form of a paragraph. Let's make the greeting more dynamic. Inside the script block, we're going to export an object. The object we're exporting will be used for the component settings. This is where you should add your data, methods, computed properties, and watchers. Everything's the same as before. Before we jump into adding the data, I want to assign this component a name. We'll add a property called name. The name property isn't required, but it can be useful for debugging. The Vue developer tools will use this property for the name of the component. Sometimes Vue will display components as anonymous when it doesn't know what name to give it. By assigning a name to your components, it'll become easier to identify them in the developer tools. We'll set the name option to app. You can name your components whatever you want. Generally, you should keep it to alphanumeric characters and hyphens. Next, let's set up the data function. Inside this object, we'll add the property message with a value of hello world. Next, we'll replace the static text in the template with the expression message. Let's give things a test. Inside the command line, run the command npm run dev. You shouldn't receive any errors thus far. We'll preview the app in the browser. We'll see the message get outputted in the browser. This confirms the component is working. Almost everything we've learned so far still applies to components. The main difference is that we have a better separation of logic. It's much easier to work with components when the template has syntax highlighting. If we were to open the Vue developer tools, we would find the component with the name we gave it inside the name property. Once again, this is useful for debugging. The dev tools tend to give some components the name anonymous. Assigning a name to your component will stop that from happening. The developer tools will capitalize the name for you if you decide to keep it lowercase. That's the basics of creating a component with single file components. We'll continue exploring what else we can do with component files in the next lecture. In this lecture, we're going to move on to the next step, which is creating child components. We already saw how to do this previously, but there are a couple of additional things I want to show you. What we'll do is put the greeting into its own component. It shouldn't be difficult to pull off. In fact, why don't you give it a try? Try creating a greeting component with a dynamic message. Then try loading it inside the app component. Pause the video and good luck. Welcome back. If you were able to take on the challenge, then congrats. If not, that's fine as well. We'll do it together. The first step is to create the file. It's always good practice to keep your components organized. We'll place our child components inside a separate directory. Inside the source directory, create a folder called components. Inside this newly created directory, create a file called greeting.vue. It's common practice to use camel casing for your component names. It's not required, but recommended. Inside this file, we'll want to add the template and script blocks. We can type those blocks out, but there's an easier way to create them. Switch over to the Extensions tab. There's an extension created by the community of Vue for creating components. Search for an extension called Vue vs Code Snippets by a user called Sarah Drasner. Install this extension on your editor. It's going to be helpful. After installing it, switch back to the greeting component. If I start typing Vue, then Visual Studio Code will provide me with a drop-down of snippets I can add to the file. This is possible thanks to the Vite extension we installed. If you're not using either of those, then you'll need to type out the blocks manually. You can select any of these options, and Visual Studio Code will pre-fill your file with the snippet you selected. I typically like to go with the very first one. After selecting it, all three blocks are inserted for us. We're going to remove the style block because we won't be using it. In addition, the setup attribute can be removed. For the rest of this course, I'm going to use this shortcut whenever we create single file components. Unless I say otherwise, I will also remove the style block whenever I do so. It's not something we will use often. Let's continue working on the component. For the template, we're going to cut and paste the paragraph element from the app component to the greeting component like so. Next, we're going to copy the contents of the script block from the app component. We'll paste it into the greeting component. We're going to need to make one change to the greeting component. We'll change the name to greeting. We're finished with prepping the greeting component. The next step is to load this component inside the app component. Switching back to the app component, we don't need the data property anymore. It has been moved into its own component. Therefore, we'll remove the data function. The next step is to load the component. There are two ways to load a component. You can do it on a global level and on a local level. We learned how to do it on the global level previously. To register a component globally, we need to use the component method. Let's use this method inside the main.js file. This is the file where we are initializing the Vue application. We'll need to make some adjustments to the way we initialize the application. Currently, we're chaining the mount method. However, we need to register the component before we mount the application. We'll separate this by assigning the returned value from the function to a variable called VM. Afterward, we'll chain the mount method to the variable. In between these two lines, we'll register the component. Components must be registered after a Vue instance. We'll call the component method on the VM variable. At the top, we'll import the greeting component. There are two things I want to quickly note about this import statement. We're including the Vue extension in the import statement. We need to make sure Webpack understands we're importing a single file component. Be sure to include this extension in the import statement. Secondly, the name of the import is called greeting. This is the same name in the component's name property. This is common practice so that it's easier to find the component, but you can call it whatever you want. You don't have to use the name you assigned in the name property or the file name. From here, we can pass in the name of the component, which will be greeting, and then the component itself. We don't have to worry about passing this in as an object. Webpack will compile it into an object. Vue will understand what we're trying to do. This is how you register a component globally. Global components can be used anywhere in Vue. This includes children components. However, this usually isn't recommended. Global components tend to make optimization harder for module bundlers like Webpack. Our application will still work, but it's best practice to register a component locally. That way you don't end up loading every single component in your application, even the ones that aren't active. Let's learn how to do that. We're going to comment out both lines. Local components can only be used in the component it was registered in. The app component is the only component we have that will be using the greeting component. To register a component locally, we can add a property to the configuration called components. The value for this property is an object. The object will contain a list of components that can be used inside this component. Like last time, we'll need to import the greeting component. Next, We'll add a new property to the object where the key name will be the name of the component and the value will be the component itself. The key name will be greeting. The value will be the greeting component. Thanks to ES 2015, we can shorten this to greeting. It'll automatically be interpreted to what we previously had. This is how you register a component locally. The components property allows you to specify what components the current component can use. The last step is to use the local component. In the app components template, we'll add a pair of tags with the name greeting. Let's refresh the page in the browser. We will still see the greeting in the document. Using the View Dev tools, we'll find the greeting component nested inside the app component. This confirms that our app is using the greeting component we registered. Checking the dev tools is a great way to verify if a component is being registered successfully. Vue gives us the flexibility of registering a component globally or locally. I always recommend local registration unless you know for sure that a component will be used in multiple locations. In the end, it's completely up to you. It's all preference. In this lecture, we're going to discuss how to add styles to a component. There are a total of 3 blocks in a single file component. The template block is for your component's template code. You can insert expressions, directives, and use other components. The script block is for your component's options. This includes the data, methods, and business logic of your application. You will most likely use both blocks in almost every component. There is one additional block, which is the style block. Its purpose is simple. It's where we can define the styles for a component. We previously removed it. Let's add it back into the greeting component. From here, we can apply any stylings we like. Let's change the color of the paragraph to the color red. Next, let's try viewing the page again. Make sure your server is running by running the npm run dev command. After viewing the page, we will see the paragraph with the text color changed to red. This works, but it's not perfect just yet. We're going to inspect the element to view the paragraph styles. The color change is going to apply to all paragraph elements. It would be more ideal if the color change would apply to the paragraph elements in the component. The first solution would be to use IDs and classes. That would work, but Vue provides another solution you may want to consider. In the future, browsers will support something called the Shadow DOM. The Shadow DOM makes it possible to have multiple DOMs inside your document. The main benefit of the Shadow DOM is that it lives in its own little world. Any changes you make to that part of the page will only be reflected on that part. Vue is able to do something similar with its virtual DOM. You saw an example of this with the data property. Any data defined in a component is isolated to that component. Vue is able to isolate styles to a component. It borrows that idea from the Shadow DOM. The Shadow DOM is not to be confused with the virtual DOM. The virtual DOM is a JavaScript object that is a copy of the real DOM. The Shadow DOM is an isolated DOM from the real DOM. Let's learn how we can isolate styles to a component. First, let's create a paragraph tag outside of the greeting component. We'll add one inside the app component above the greeting component. It'll contain some static text. Next, switch back to the greeting component. We're going to add one simple attribute to the style block. The attribute we'll want to add is called scoped. By adding this attribute, Vue will compile the template while making sure the styles are only applicable to the component. To better understand what will happen, let's read the documentation. In the resource section of this lecture, I provide a link to the scoped CSS documentation page. Here is what Vue has to say about scoped CSS. When a style tag has the scoped attribute, its CSS will apply to elements of the current component only. This is similar to the style encapsulation found in Shadow DOM. It comes with some caveats, but it doesn't require any polyfills. Below are some examples. In the first code snippet, the scoped attribute is added to the style block. The second code snippet shows what the final result will be. Vue will add a data attribute to the elements from the component. The CSS selectors are modified to select an element based on the data attributes added to the elements. It's done for you automatically behind the scenes. This allows you to keep your code fairly minimal. We don't need to use ID or class names to achieve the same results. The styles we apply to a component will not affect elements outside of the component's template. Let's view the application one more time to see the result. There are two paragraph elements, one from the app component and another from the greeting component. We added a scoped style to the greeting component. It'll change the color of any paragraph elements to the color red. The paragraph inside the app component doesn't get changed to the color red. Only the paragraph tags inside the greeting component are changed. If we were to inspect the element, then we'll quickly find a data attribute has been added to the element as noted in the documentation. This was added in when the template file was compiled. One question I get asked is, why does Vue choose to mimic the behavior of the Shadow DOM instead of actually using the Shadow DOM? The Shadow DOM is not completely supported in all browsers. Therefore, Vue will simulate the behavior of a Shadow DOM by adding additional details to your component. Despite the change, the concept is still similar. We can continue to make changes to the paragraph tag or any other elements inside the component. Those stylings will only be applied to the component itself. Sometimes you may want to check if the stylings are correctly loading in the document. If we were to go to the head section of the document, we'll find a style tag that's been dynamically added. Vue will generate a style tag with the CSS you've written for the component. That's the basics of adding styles to your components. We've learned how powerful scopes styles are. One of the major benefits of using scoped styles is that we didn't have to worry about dealing with classes or IDs. We didn't have to worry about stylings leaking into other areas of the page. This keeps our stylings clean and concise. We're using plain CSS at the moment. What if we wanted to use Sass? We'll look at how to use Sass in our application in the next lecture. In this lecture, we're going to learn how to use Sass in our project. The CSS we've written in our components is being processed as plain CSS. If you watched the previous section, you may be aware that I introduced Sass. The project we are currently working in does not have Sass installed, but it's easy to add if you prefer to use Sass. If you have the server running, then you will need to turn it off. Otherwise, we won't be able to install additional modules. Afterward, inside the command line, run the following command: npm install sass save dev. Next, open the greeting component inside your editor. We'll add an attribute called language to the style block. Its value will be scss. Our project is now using Sass. The great thing about using the preset that came with the Vue CLI is that it's configured to use most CSS preprocessors like Sass. Adding the language attribute will instruct the compiler to use the preprocessor for the language you're specifying. Let's give it a try. Update the selector with the hover pseudo-selector. Next, set the color property to the darken function with the following arguments: #cc4444 15%. Lastly, we'll turn on the server. We'll refresh the page one more time. Sure enough, the stylings still get applied. The Sass code gets compiled into CSS. It's a very simplistic approach to writing CSS. There's a lot more to using CSS in Vue, but we'll get to those subjects later. I encourage you to read the documentation to help you get a better understanding on how to use CSS in Vue. The more advanced topics are things we'll get to once we need them. We've learned how to create components and use them within one another. Any data you put inside a component will belong to that component. This means that you can have two components with the same property names without having to worry about naming collisions. This works for some scenarios, but there will be other scenarios where you'll want to communicate data between each component. Let's look at this diagram for a moment. We have three components. Component A is the parent component to component B and C. Component A is also known as the root component because it sits at the top of the hierarchy of components. Components B and C are not just children components to component A. They're considered sibling components to each other. This is because they sit on the same level in the hierarchy. Parents, children, and siblings are all terms you'll hear when discussing components in relation to each other. Let's take a look at how this will apply to what we're going to do. We're going to have three components for this example: the app, greeting, and user components. The user component currently doesn't exist in our project. We'll be adding it shortly. In this application, the user component will have a property called age. The greeting message will be based on the user's age. If their age is below 25, then we don't want to greet them. If they're above 25, then we will greet them. The question is, how do we send the age to the greeting component when it's stored inside the user component? The solution may be to send the data over to the sibling component, but that's currently not possible. Vue doesn't offer a way for components to send data to their siblings. If it isn't possible to send data to sibling components, then how do we share data? The real solution is to store the data inside the app component. We'll be able to send it down to the children components. Parent components are able to send data down to their children components. Therefore, it would make sense to store the data inside the parent component. From there, we can send data to components that need them. Data that is sent to components are called props. They're another way of adding data to your component. Let's learn how to use them in the next lecture. In this lecture, we're going to learn about how to use props in our components. You can think of props as custom attributes for our components. We can use props to customize the behavior of a component similar to how HTML attributes change the behavior of an element. Let's prepare our project. We'll start things off by creating the user component. Inside the components directory, create a file called user.view. We'll add the template and script blocks. Next, export an object with the name property assigned to the value of user. We'll keep the template simple. It'll be a set of paragraph tags with the following text. The user is X years old. The user component is ready. The next step is to register it inside the app component. Inside the app component, we'll register the user component. The user component has been registered to the app component. We'll add the user component below the greeting component. Something I want to note is that the component can be written differently than how you define it inside the components object. Vue will use the name of the property as the name of the tag. You have the option of writing the tag name with lowercase letters even if the property name is using uppercase letters. In this example, we're using the lowercase version for the tag name. Vue allows you to write it either way, which can be nice since most element names are lowercase to begin with. We're going to change the greeting component to use the lowercase version. From here on out, we'll use the lowercase versions of components names inside the template block. One final adjustment. We're going to change this paragraph tag to an H3 tag. We're doing this so that it can stand out a little more when we're working on the application. Before we start adding data into the mix, let's confirm that the code is working. We'll refresh the page. Surely enough, everything is working properly. The user component is loading in just fine. We'll open the app component. We're going to add the data to the app component. not the user component. This way we can pass it down to both the greeting and user components. We'll add the data function using ES6 syntax. Inside this function, we'll return the object with the age property. We're giving the age property a value of 20. With the dataset, let's pass it onto the user component. Inside the template, we're going to add an attribute to the user component. In order to pass down data, we need to pass it in as an attribute. The attribute name can be whatever you want as long as it doesn't conflict with other attribute names. I recommend naming it something relevant. Since we're passing down the age, I think it would be appropriate to call it age. The value of this attribute is what will be passed onto the component. We want to pass down the age data property. You can hard code the value or you can make it dynamic. It's important to understand that the value will not automatically be interpreted as an expression. You have to bind it if you wish for it to be an expression. If we were to pass it like this, then Vue will assume you want to pass down a string. Therefore, we'll have to add a colon before the name to bind the attribute. Now Vue will send the age property inside the data object. We're not finished yet. The user component needs to accept the age. Switching to the user component, we're going to add a new property to the exported object called props. Props is short for properties. This will be set to an array. The array should contain a list of properties that the component will accept. We're going to accept the age. It's important that the name inside the props array matches the attribute name. This is how Vue connects the two. The age property is now available in our component. You can use it in expressions, directives, and methods. Inside the user components template, we'll replace the X in the static text with an expression that'll use the age. There's nothing more we need to do. Let's refresh the page. The user component displays the age dynamically. Even though there isn't a data property inside the user component, it's still able to use the age as if it were its own. The great thing about this is that the age will automatically be updated if the age in the parent component changes. Any changes are trickled down to children components. I can even prove this to you. Using the Vue dev tools, view the list of components available. The app component will have the age under the data category. If we were to view the user component, it'll have the age listed under the props category. Despite being in a different category, we can still use the age like any other data property. If I were to switch back to the app component, I'll be able to edit the age. If I increment or decrement the value, then you'll notice the age up top changes as well. If the data inside the parent component changes, then all children components will reflect that change too. Vue handles that process for you. However, it doesn't necessarily work in the reverse. If we were to attempt to edit the age inside the user component, then we'll quickly discover it's not possible. There are a couple of reasons for this which we'll explore in the next lecture. In the previous lecture, I showed you how to pass down data to a component. Once the data has been passed down, the child component can use the data in expressions, directives, and methods. However, there are some limitations you should be aware of, specifically on how you update the data. Before we review the limitations, let's pass the age onto the greeting component too. Inside the app component, we're going to pass on the age to the greeting component. It'll be the same as before. We'll bind an attribute called ageSet to the age data property. Inside the greeting component file, we'll add the props property and accept the age property. The next step is to use the age. Right after the first paragraph element, we'll add another one with the following message. You must be 25 years or older to view this message. For the first paragraph, we'll add the VIF directive. The condition will be age greater than 25. The second paragraph will have the VElse directive. The first paragraph will be rendered if the age property is greater than 25. By default, the age is set to 20. This will return false. As a result, the first paragraph will not be rendered. The second paragraph should render since it has the VELSE directive. This is a very simple use case of conditional directives. This will always display the second message because we have no way to change the age in the application. Let's add a button that will do just that. Inside the app component, we'll add a button below the heading. We're going to listen for the click event and increment the age whenever the button is clicked. With those changes made, let's check out the application. Initially, we'll be greeted with the second message. If I were to click the button, then the first message will eventually appear. Both the greeting and user components are updated with the latest changes. This works fine. We don't need to make any adjustments to either component since the change is occurring in the parent component. However, you may want to change the data directly inside the child component. Let's try moving the button from the parent component to one of the children components. Back in the editor, we'll cut the button and place it directly inside the user component. This will result in an error because we are not allowed to mutate props. The reason we aren't allowed to do this is because the parent component will not be notified of the change. The changes will not be reflected in other components too. Another downside to updating a prop in a child component is not being able to hold on to those changes. If the parent component updates the age, those changes will override the changes in the child component. The parent component has priority over changes to its data. This means that the user component will use the age inside the app component instead of using its own version of the age. This is a problem as you may want to make changes to data inside children components, but have those changes reflected in all components. This includes sibling components like the greeting component. How do we let the greeting component know the age was updated? We'll discuss a solution in the next lecture. In this lecture, we're going to learn how to update props from the child component. Props are not allowed to be updated in child components. This introduces bugs and unexpected behavior in our application. But what if we need to update a prop from a child component? We're going to be doing something called emitting events. The word emit means to produce or trigger something. When you click on a button or element, JavaScript will emit a click event. It doesn't call any specific functions. Instead, any code that listens for that event will run. We're not limited to the standard JavaScript events. We're allowed to emit custom events. Vue makes this process easy by providing a function that does just that. After emitting a custom event, we can listen for those events in our application. We already know how to listen for events. All we need to learn is how to emit them. It's quite simple. Inside the user component, we're going to change the expression inside the click event. Rather than incrementing the age, we're going to call the function onClickAge. Next, create the methods object and define the onClickAge function. We'll be using the shorthand ES6 syntax version for defining the function. The next step is to emit an event. Vue has a special function for doing this. We can emit an event by calling the $emit function. This function will emit an event that other components can listen for. Something I want to point out that I mentioned before is the function starts with a $. Vue likes to name its own functions and properties with a $. This makes it easy to tell the difference between an official Vue function and some function by other components or libraries. It's a simple way to differentiate between things. Alright, moving forward, this function requires one argument. It requires the name of the custom event. You can call this whatever you want, but I always recommend keeping it simple and concise. We'll set this to age change. We're almost finished. Any parent components can listen for the event. The next step is to have the parent component listen for this event. we're going to listen for the event inside the app component. This is because only parent components can listen for events from children components. This event is inaccessible to the greeting component. That's fine, as the app component is a parent component to the greeting component. If we change the age inside the app component, then all children components will update as well. To listen for an emitted event, we can use the vOn directive. We'll apply this to the user component, but with the shorthand syntax. The name of the event is the name we used in the first argument of the emit function. In this instance, this would be age change. Listening for a custom event is the same as listening for any standard JavaScript event. From here we can run an expression. We'll increment the age. This is what will happen. When the user clicks on the button inside the user component, this will run the function onClickAge. The onClickAge function does one single thing. It will emit an event called ageChange. Any components that are using the user component will be able to listen for any custom events emitted from it. That's exactly what we do in the app component. To listen for an event, you use the vOn directive or the shorthand version @. You listen for the event like any other event. If the event is triggered or emitted, then the expression inside it will run. In this example, the age is incremented. Let's test if this is true. Try clicking on the button in the browser. Initially, the age will be 20. The age will increment by 1 on each click. If it surpasses 25, then the greeting component will update with the appropriate message. This is exactly what we wanted. We're no longer updating the age inside the user component. We're simply emitting an event. The app component is what changes the age. Since the age gets changed inside the app component, then all children components get updated with the age as well. Admittedly, it's quite a few steps to do, but you'll get used to it the more you practice it. Let's take it a step further. In some cases, we may want to pass data from the event to any listeners. For example, let's say we wanted to pass on the value that should be added onto the age. Inside the user component, we can pass an additional argument to the $emit function. The additional arguments will be passed on to any listeners. We'll pass in the number 3. This is what will be passed on to any listeners. To use this value, we'll need to update the code inside the app component. Instead of incrementing the value, we'll call a function. The name of the function will be updateAge. Next, we'll add the methods property to the object below. We'll define the updateAge function. We'll accept the number passed in as num. Lastly, we'll add the number to the age. Refresh the page and try testing out the button. Instead of incrementing the value by 1, it will increment by 3. Passing in values is very simple. There are 2 steps to the process. First, you pass the data as you're emitting the event. Second, you can update your expressions to run functions that accept in the data. In the console, we'll receive a warning by Vue. It's telling us that we should add the emits option to the user component. This is because Vue wants to know what events the parent component can expect from the child component. Back in the editor, we'll update the user component. We'll add the emits option. This will be an array of events that will be emitted from the component. We'll add the age change event to the array as a string. The reason Vue recommends adding emits option is because it helps document what the component does. It's a recommended good practice. One last thing I want you to be aware of. This process is only necessary when we need to make changes to any of the props. We can continue to use props inside computed properties or methods. It's perfectly fine to use props as read-only values. Let me show you an example. Inside the user component, we want to display the age doubled. Switching to the user component, we'll create a computed property called age doubled. Inside the function, we'll return the age property multiplied by 2. Every prop is accessible directly via the this keyword. View will take care of proxying the value. In this example, we're not directly changing the prop. Instead, we're grabbing the value and using it to create a whole new other value. We'll create an expression inside the template to output the age doubled computed property. Refresh the page after making those changes. The age has been doubled. This is because we're not directly changing the value. If I press the button, then the age gets incremented like before, but the user component is still doubling the value. With every change, we still don't get any errors. Once again, this is because we're just grabbing the value. We're not changing it. If you plan on using the value, but not changing it, then it's not necessary to use events. That's very important to know, as you don't want to end up writing too much code. We've learned how to add props to our components. Their data passed down from a parent component to a children component. We can take it a step further by validating the values. Validating a prop can be useful for debugging your application. If you have a component that's used in dozens of locations, then you may want to make sure that a prop is a specific data type. By adding validation, you can catch if a component is passing in the wrong type of data, allowing you to fix it before shipping your app to production. Validating props is very easy. Inside the user component, we're passed down a prop called age. The age should always be a numeric value. Let's validate it. Rather than passing in an array, we can pass in an object of props to accept. Each property in the props object will represent a prop. The key name is the name of the prop. We have one prop called age. The value of this should be an object. The object will contain the validation rules, if any. The first rule you can set is the type. The type is the data type the prop should be. All JavaScript types are supported, such as string, number, object, array, etc. In the resource section of this lecture, I provide a link to the types you can use. There are additional types like date and symbol available. If we scroll up above, we'll find examples on how to validate props. Feel free to read over this once you're finished with this lecture. Let's switch back to the component. We'll set the type to number since we want numeric values. We're not limited to one data type. You may want to allow multiple data types. If this is the case, you can replace this with an array and then add the data types you'd like to accept. I can add in number and string. I'm going to revert this back since I want to restrict this to numeric values. I just wanted you to be aware that it is possible to check for multiple data types. We're not limited to checking the data type. We can make the prop be a required value. In the object, we'll add a property called required. Its value will be set to true. Anytime a component uses the user component, they're required to pass down an age. If they don't, then it'll throw an error. Let's test out both rules. Switch to the app component file. Let's remove the age prop from the user component in the template block. Next, let's refresh the page. Upon refreshing the page, we will get an error inside the console. It's telling us that the user component is missing the age prop. It's also telling us that this error can be found inside the app component file. Pretty useful information for debugging the application. Let's add the age back in. After making that change, the error inside the console will disappear. Now let's try testing if the type rule works. We're going to open the View Dev Tools. The age can be found inside the app component. We're going to change the value to a random string. After changing the value, an error will appear in the console. It says the following: invalid prop. Type check failed for prop age. Expected number got string. This shows that the type rule works. Once again, I want to stress that this is really useful for debugging purposes. If you're using a prop that is generated by user input, then there's not much you can do to prevent them from passing in an invalid type. Even with form validation, there's still a possibility for this error to appear. Just be aware of that when using props. There's more we can do with validation. We can set a default value. Back inside the user component, we'll add a new property called default and set it to 20. Since there's a default value, we don't need to have the required property. We'll comment it out. With the default key set, we're always assured that the prop will have a value even if one is not passed down. Something I want to note is that the default key must be set to a function if the type key is set to be an object or array. The function must then return the object or array. This is one of those weird quirks of using the default key. So far we've covered the three main ways to validate the prop. Sometimes this may not be enough. You may want to have custom validation. That's possible with the validator property. We'll comment out the default key. Then we'll add in the validator key. The validator key must be set to a function. The function is passed in the value of the prop. We'll be able to perform validation on the prop value. The function expects you to return either true or false. If true, then the validation passes. If false, then the validation fails. Inside this function, we're going to return the following: value less than 130. The condition will check if the value of the prop is less than 130. If it is, then the condition will pass and the value returned will be true. Therefore, the validation will pass and the application can proceed like normal. The reason I'm checking if the age is lower than 130 is because there isn't anyone who is over that age. It wouldn't make sense for anyone to be older than 130. We'll refresh the page to test this out. We'll continuously click the button until the age exceeds 130. Surely enough, we get an error in the console saying invalid prop. Custom validator check failed for prop age. Fantastic! As you can see, Vue provides a lot of flexibility for validating your props. You could probably add a mechanism for preventing the age from exceeding the maximum age to prevent this error from being triggered. Try doing that on your own as a fun side challenge. One last important note I want to add in before I end this lecture is that the validator functions run before the instance of the component is created. Therefore, you won't have access to the data, computed, or methods properties inside the function. For example, back in the editor, we'll try calling the onClickAge method inside the validator function. Switching back to the page will tell me that the method is undefined. This is important to know as you may try to access other parts of your components and run into errors after doing so. It's because the Vue instance hasn't been created. Therefore, you won't have access to any proxy methods or properties. I'll comment out the line before proceeding to the next lecture. Emitting events has proven to be the best way to update data in a parent component from a child component. There are libraries out there that make sharing data between components easier. We'll get into those later in this course. In this lecture, I want to introduce an alternative solution for updating data in the parent component from the child component. Callback functions can be used to update data. If you are familiar with React, then you will feel right at home with this method of sharing data. Creating callback functions is a very simple process. Let's explore how to create one. Inside the app component, let's create another method called updateAgeCB. It will do the exact same thing as the updateAge function. I'm creating two versions of the same function so that we can compare the difference. We're going to pass this function down to the user component. You heard that correctly. You're not limited to sending down primitive values. You can also send down functions, objects, and arrays. We can pass this function to the user component just like we would for any other prop. Inside the template, we'll bind an attribute to the user component called AgeChangeFN with the value of UpdateAgeCB. The letters FN are short for function. Let's switch over to the user component to accept this function as a prop. We're going to set this to function. We're not setting this to an object like we did with the age. If you are only planning to check for the type, then you don't need to set this as an object. Instead, you can directly set the type. That'll work fine. With the function added, we can use it in our code. Inside the template, we're going to make a copy of the button. However, this time we're going to directly call the callback function. We'll pass in the number 3. We're going to update the text inside both buttons. We want to be able to tell the difference between the two. Let's refresh the page to see what happens. If I were to click on the second button, then we will see the age increment by 3. The app component will continue to update the age. Both children components are provided with the changes. When we use the callback, we're basically passing in the function to the child component. However, when we call the function inside the child component, it's not like the child component has a copy of the function. Instead, it's calling the function inside the parent component. The function inside the parent component will have access to the data. Therefore, that is where the data will change. At this point, you may be wondering, which is better? Should you use callback functions or emit events? It really comes down to preference. As far as performance goes, both methods of communicating data are about the same. You won't see any significant performance gains from using either one. According to Vue, it's recommended to use events. Most examples you'll find in the documentation use events. For consistency reasons, I recommend using events. There is one advantage to using emitted events. I'm going to refresh the page. Then, inside the Vue Dev Tools, I'll switch to the Timeline tool. The Timeline tool will display a list of events emitted by our app. It'll even display events emitted by the browser. There are 3 categories of events. I'm going to click on the button that emits an event. After clicking this button, an event has been logged. We can click on this event and view the details of what the event was. We're given the name of the event. We're also provided the source. It tells us that the event was emitted from the user component. Lastly, we're given the payload. The payload is the data that was sent with the event. All of this information is useful for debugging the application. If I were to click on the callback button, then nothing will get logged, not even in the console. This makes things a bit harder to debug. Of course, you could log this manually, but that can cause more headaches than it can solve. If you were to change any names, then you would have to change the log information. With events, the names are already logged for you, so there's no need to do it yourself. This is one of the main reasons you would want to use events. On top of that, most tutorials and documentation use events for communicating data between components. Therefore, you'll see a lot of applications using that practice. At the end of the day, it's up to you. You can use callback functions or emit events. In this lecture, we're going to learn how to use slots in our component files. Slots are a great way to pass down content from a parent component to a child component. They are an alternative to using props. Slots are very popular among library developers. It would be beneficial to understand how they're used. They can be really useful when you need to make your code more reusable. What do I mean by that? Well, let's look at a real use case example. We'll be working on a new project for this example. In the command line, run the following command: npm init view at latest. During the setup process, set the name of the project to slots. Next, select no as the response to all questions. We're going to be working with the bare minimum. Lastly, we'll move into the new directory. The packages must be installed. Run the npm install command. Next, let's start the server with the npm run dev command. Let's do some cleanup. In the Components directory, delete all component files. We won't need them for this demonstration. Up next, we'll update the app component. We're going to remove the style block from the component. Then, we'll strip the template and script blocks to the bare minimum. From the script block, export an object under the default namespace. Set the name property to app. We're ready. Let's start working with slots. Inside the template, we're going to create a simple form. The form will have 3 intersections. We'll use div tags to create these sections. The sections will be called Help, Fields, and Buttons. The Help section will contain some help text to inform the user on how to fill out the form. The Fields section will hold the input fields. Lastly, the Buttons section will hold the submission buttons. We're going to fill out each of these sections quickly. This is how forms are typically built. You split everything into sections to keep your markup structured. It's a common methodology of approaching forms. I'm not using any expressions or directives inside the form. It's just plain HTML. You can think of this as a login form. We can improve the form by putting it into its own component. It's getting rather large, so placing the logic in a separate component would be a good idea. Let's do that. Inside the Components directory, create a file called form.view. We'll add the template block to the file. We're not going to bother with the script block at the moment. The goal is to move the form into a separate component. We'll cut the form element from the app component. Then, we'll paste it into the template block of the form component. We'll want to register the component locally. Switching back to the app component, we'll import the form component. Next, we'll register the component by adding the components object to the exported object. We're prefixing the name with the word app. That's because there's already an element called form. We don't want to have a naming conflict. This is another reason why it's always considered good practice to namespace your component names. Back in the app component file, we'll add the form component where the form was originally located. I'm lowercasing the words and adding a dash between them. This is an alternative way to write components. In an earlier lecture, I talked about how you can use kebab case or Pascal case for your component names. If you opt into using Pascal case, Vue will allow you to write the component with lowercase letters. It'll add a dash before each letter that was capitalized with the exception of the first one. We can use the original name, but I like to use the lowercase version because it keeps things consistent inside the HTML. Native HTML elements are always lowercase. Alright, let's move on over to the browser. Surely enough, the form gets rendered. There's nothing wrong with the form, but there are some limitations with the component. A form is a common UI element in any application. It's likely that you'll have multiple forms. Some examples would be a login form, register form, contact form, etc. They may have different input fields and objectives. However, they may look visually consistent. This means you're probably using the same markup structure and classes. It isn't just forms that suffer from this problem. Most UI elements are reusable. If we were to go back to the application, we wouldn't be able to reuse the component. Instead, we would have to create another component if we wanted to reuse the form. Let's say we wanted to create a contact form. The contact form would use the same base HTML, but with different input fields. I want to be able to reuse the form component. We could do this a number of ways. For example, we could use props and pass down the stylings and fields. That's a viable solution, but passing down HTML through props isn't really fun. This is especially true if you have complex markup. The recommended solution is to use slots. We'll create the second form in a moment, But first, let's explore how to create a slot. Before using slots, you need to identify which parts of your component are reusable or unique. Inside the form component, the markup that will be unique are the 3 sections inside the form. I'm going to cut all 3 sections. Then I'll transfer them over back to the app component. We're going to paste the markup inside the app form component like so. Vue allows us to pass down markup in between the components tags like we're doing here. However, this won't work just yet. We have to instruct Vue where to render the markup in the child component that's receiving the markup. Switching to the form component, we're going to insert a tag called slot. We'll insert it inside the form element. The slot tag we're using is a component created by Vue. It'll get replaced by the content that gets passed from the parent component. Let's move over to the browser to view the result. The form renders normally. Slots are a way to pass down markup from the parent component to the child component. In this instance, we're passing down these sections to the form. The slot tag we have inside the form component will be replaced with the content passed in. There may be some scenarios where no content will be passed in. We have the option of rendering default content. Back in the editor, in between the slot tags, we can add some default content. We'll add the following: no form to render. If content is not passed down from the parent component, Vue will use the content inside the slot component. We can test that out by switching over to the app component and using the form component twice. For the second copy, we'll leave it empty. Hopping on over to the browser, we will see the first form rendering. The second form will have the message inside the slot rendering. Having default content is optional and can be useful just in case you forget something. This is the basics of creating slots. We'll stop here. In the next one, we'll look at how we can further improve this solution. In this lecture, we're going to explore how to create named slots to optimize our component. First, let's update the second form with some inputs. We'll turn it into a contact form. Inside the app component, we'll copy the content passed into the first form. We'll paste it in as the content for the second form. Next, for the second form, we'll change the help desk and the input fields. We have 2 forms using the same component, but with different inner content. Let's test if this works. Inside the browser, the 2 forms will render without a problem. The main benefit of using slots is the ability to create one component that will act as a skeleton. The form component is some base markup with a slot for the parent component to insert content into. By having a skeleton, we only need to create one component. We didn't have to create 2 separate components like a login component and contact component. We have a generic form component instead. In a sense, this makes the component more reusable. This is what slots are mainly used for. To be truthful, this component isn't the best example. In a real-world example, your skeleton would most likely have much more markup than just a form element. It would be beneficial if we could distribute the content better. That's possible with something called named slots. For instance, inside the app component, the markup between both forms have the same 3 sections. It would be better if we could leave these sections inside the form component. We'll switch back over to the form component and add in these 3 sections again. They were the help, fields, and buttons sections. Inside the help section, we'll insert the slot component again. This time, we'll add an attribute called name. We can assign slots unique names by adding the name attribute. We'll give this slot the name of help. By assigning a name, we're given more control over where the slot content is distributed and placed. This also allows you to have multiple slot locations. We'll add slots to each section with the name attribute. We can call our slots whatever we want. I recommend giving them something relevant. There will be a slot for the Help, Fields, and Buttons sections. We can go back to the app component to use these sections. Instead of using the class attribute, let's change each of these to the vSlot directive. The vSlot directive can be used to tell the child component where the slot content should be placed. We need to add a colon after this directive followed by the name. The name corresponds to the value we used for the name attribute in the child component. We'll assign this part of the content to the help section. The second div element will be for the field section. Lastly, the third div element will be for the buttons section. We'll do the same for the second form. By using the vSlot directive, Vue will be able to identify where to load the content in the child component. There's one problem with this. The vSlot directive may only be applied to template tags. This is a limitation you should be aware of. We can't use this directive on the div element. The solution is simple. We'll replace the div tags with template tags. Let's check if everything worked. Switch over to the browser to check the application. Both forms are functioning correctly. Thanks to named slots, we have more control over how content is distributed from within the component. We aren't limited to using named slots. We can use a combination of named slots and default slots. Let's go back to the editor. Inside the form component, we'll add a slot at the bottom of the form. By having a slot with no name, any elements that aren't assigned to a specific slot will be put there by default. Back inside the app component, we'll add a paragraph tag at the bottom of the first form with some dummy text. If everything I said was true, then the paragraph tag should be placed at the default slot location. Upon refreshing the page, we'll find the paragraph element added to at the default slot location. We can use a combination of named slots and a default slot. It's up to you. We can take this a step further. One advantage of slots is the ability to use data from the parent component. Let's try that out. Inside the app component, we're going to create the data function. We'll create one property called help that will contain the help text from the first form. We can use this data property inside the content itself. We don't have to use a prop to pass it on. Inside the first form, we'll replace the help text with the expression help. This will work because technically we're still inside the app component. Since that's the case, then we still have access to the data, computed properties, and methods inside this component. Therefore, there's no need to pass this down as a prop. Hopping back to the browser will show that the expression works as expected. If you don't plan on using the data inside the child component for functions or computed properties, then there's no need to use a prop. This is a perfectly fine alternative. As you can see, slots can provide for a more interesting way of structuring your application. In the resource section of this lecture, I provide a link to learn more about slots in Vue. I recommend giving it a good read if you want to know what else you can do with slots. The last thing I want to go over in this section are dynamic components. A dynamic component is a component that can be swapped with other components. This allows you to toggle between components. Using dynamic components isn't difficult, but there are a couple things you should be aware of when using them. I'll discuss everything you'll need to know in this lecture. We're going to work in a new project. Using the command line, run the following command: npm init vue at latest. Set the project name to Dynamic Components. Select No for all questions. Lastly, let's move into the newly created project. Inside the new project, install the packages with the npm install command. After moving into the new project, be sure to turn on the server with the npm run dev command. Since this is a new project, we'll need to clean things up a bit. Inside the components directory, delete any components created by the CLI. Open the app component file next. We'll want to remove a lot of the content. We'll delete the style block. The template and script block will be emptied out. Lastly, export an object with a property called name with a value of app. We're starting fresh to focus on the idea of dynamic components. We'll need to create some new components for showing how dynamic components work. You'll see what I mean in a moment. We'll create two components called About and Home inside the Components directory. For the About component, we'll add the template block. Inside of the block, we'll output a message. We'll do the same with the Home component. We have two distinct components. I want to display the component depending on a user selection. We'll create a drop-down where the user will be able to select what component they'd like to view. Switching back to the App component, we'll create a drop-down menu. We'll add two options which will be Home and About. We'll use the drop-down to select the component we currently want active. First, we'll need to import the components. We won't be able to use them if they're not imported. Inside the script block, import both the Home and About components. Next, register them by adding the Components option to the configuration object. After registering the components, they're available to use in our template. However, we don't want to load the components. We want to load them depending on the value inside the drop-down menu. We'll need to store the selection in the drop-down menu to keep track of what component to load. We're going to define the data function inside the exported object. Inside the data function, create a property called component name with a default value of Home. There's nothing else we need to keep track of. The component name is all we need. You'll see why in just a moment. We're going to update the drop-down next. It's what will allow the user to toggle between components. Inside the Select Form field, we'll add the vModel directive. The expression will be the component name data property. We have the drop-down working and we have the components registered. The last thing we need to do is actually load the components dynamically. Vue provides a component called component. We'll add that right below the drop-down. The component component allows you to dynamically load in a component dynamically. You can think of it as a placeholder for the actual component. To set the component to load, we need to add the attribute is. We'll bind it. The value for the is attribute must be the name of the component that's registered globally or locally. If we want to be able to toggle the component, then we'll need to bind this attribute. If you don't bind it, then the component will always load the same component passed in. The value for this should be component name, which holds the value inside the dropdown. That should do it. Let's test the application by opening it in the browser. The app is running normally. The drop-down should have the Home option selected by default. The Home component is rendering because it's the default value for the drop-down. If we were to toggle the value to About, the About component will appear. We can continuously toggle between the two components without a problem. This is how we can create dynamic components. We can use the component inside our template. Then we can pass in the component name into the is attribute. We can create some interesting interactions with this component. For example, a tabbed component or menu navigation. There is something you should be aware of though. When a component is toggled out, it gets unmounted. This means that any data inside of it will not be available anymore. If the component gets reintroduced on the page, the data will be reset to its default state. We can even view the component getting unmounted by using the lifecycle hooks. Let's use the lifecycle hook to confirm that. Back in the editor, inside the home component, we're going to add the lifecycle function. Inside of it, we will log a message indicating that the component was unmounted. After making those changes, let's refresh the page. If we were to toggle the components, the message should appear in the log. This will inform us that the home component was unmounted. Every time I toggle the home component, this message will appear. This is important to understand, as any data you have in a component will also be destroyed. Any events you may have attached to that component will become unavailable. The default behavior can work fine. Other times, you may want a component to persist. Vue provides the option of allowing persisted data. Back inside the app component, we're going to wrap the component with a component called keepAlive. This component does one simple thing. It keeps the component that's inside of it alive. Even if it shouldn't appear in the DOM, this will make sure the component lives in memory. If the component needs to be added onto the page again, Vue will use the one in memory rather than creating a new component. Back on the page, we can toggle the selections like last time. Everything works, but behind the scenes things are different. We won't see the message being logged inside the console because the component is not being destroyed anymore. Instead, it's being kept alive in memory, therefore the unmounted lifecycle hook is no longer triggered. Switching over to the Vue developer tools, we can see that both components are still inside the app component. Instead of completely removing one, Vue will set the component as inactive. This will mean that the data will still persist, but it won't appear on the page. This can be useful for when you don't want to make an additional request for the same data. Of course, this does have one disadvantage. Since the unmounted lifecycle function doesn't get executed anymore, then you won't be able to run code if the user switches off the component. You may want to run code when this occurs. Luckily, Vue compensates for this by introducing two additional lifecycle hooks that weren't available before. Inside the home component, we'll add the two lifecycle functions called activated and deactivated. Inside both functions, we're logging a message. The activated function is called when the component is active. With both functions set up, let's refresh the page. As I toggle the components, the activated and deactivated lifecycle functions are called, thus giving you the opportunity to execute code when the components are toggled. That's about it when it comes to using dynamic components. I'm sure you'll find a lot of uses for this in your applications. In this section, we're going to begin exploring how to add animations to our projects. Animations breathe life into any application. They're a great way to add pizzazz. They let the user know which parts of the app they can interact with. Whether you're adding a simple fade effect or a sophisticated slideshow, Vue is flexible enough to work with any type of animation. There are different ways to add animations. They usually fall into two categories, which are CSS animations and JavaScript animations. We'll be covering both. First, we'll start with CSS. There are two ways to add animations in CSS, which are through transitions and animations. We'll cover transitions since they're the simplest of the two. Before we get into the code, we have to understand the phases Vue will go through to add elements onto the page. Vue divides the animation into frames, which is how most animations are done. The first frame of the animation will have a class added to it called EnterFrom. For example, if you call your animation Fade, then the class name will be FadeEnterFrom. This class is removed after the first frame. It isn't alive for very long. Its purpose is to allow you to assign the element some initial properties. Along with adding a class at the beginning of the animation, Vue will add a class called Enter2. This class is added at the final frame of the animation. This class isn't commonly used, but it's useful if you want to add some finishing touches to the element after the animation is finished. The last class that's added is the interactive class. This class is added to the element from the beginning of the animation to the ending of the animation. This includes the first and final frames. With these three classes, we can accomplish a lot. Vue will take care of adding the classes for you. Enough theory, let's dig into the code. I'm inside a new project. It's based on the default project from the Create Vue package. I've emptied out the components directory. I've stripped the app component to its 3 blocks. Pause the video so you can have the same setup as me. Alternatively, you can download the project files in the resource section of this lecture. If you decide to do so, you will need to install the modules with the npm install command. In this example, we're going to show you how to animate an element when it's entering or leaving the document. We'll use a button to toggle the animation. Inside the template, we're going to add a h2 tag with some text inside. Right above it, we'll add the button for toggling the animation. To toggle the animation, we'll need to keep track of if the element should be on the page or not. We'll store it as a data property. Define the data function for the component. Inside the object, create a property called flag with the initial value of false. With a flag set, we'll add the vIf directive to the h2 tag. The expression will be set to the flag data property. This expression will make the element toggleable. It'll always remain hidden because the flag property is set to false. Therefore, we'll need a way to flip the value. We'll list for the click event on the button element. Create an expression that'll set the flag property to its opposite value. This expression is a very simple JavaScript trick to toggle the Boolean value of a variable. With that set, let's test if everything is working. Switch to the browser. Initially, the message won't appear. If we press the button, then the message will pop in since the flag property is set to true. We can continuously toggle the value without a problem. Pretty simple example, nothing we haven't seen before. The element rendering on the page is quick and snappy. It's fine, but we could definitely improve it by adding a smooth transition. I think that'll be nice. To add an animation to an element, you need to use a component called transition. Go back to the editor. Inside the app component, we'll wrap the heading element with the transition component. This component will add the classes I mentioned at the very beginning of this lecture. The classes will get applied to the elements inside the transition component, specifically the root element or the heading tag we're wrapping the component with. By default, Vue will start the class name with v. Therefore, the 3 classes I mentioned earlier will be vEnterFrom, vInteractive, and vEnter2. Most of the time, you may want to give a more descriptive set of names, a name relative to the animation currently happening. To customize the name, you'll have to set the name property on the transition component. The value for this will be the custom name. We'll set this to Fade. The result of the class names will be FadeEnterFrom, FadeInteractive, and FadeEnter2. The next step for us is to create the animation we want. Vue will not create the animations for us. It handles adding the classes whenever the element is toggled. Just because these classes are being applied to the element doesn't mean that an animation will automatically occur. We are responsible for taking it from there and specifying what will happen when these classes are applied. As the name suggests, we'll be adding a fade effect to the heading element. Inside the style block, we'll define the first class, fade enter from. This class is where you'll want to set the initial state of the element. This class gets added to the element when the element is entering the page. This class won't apply to elements that are leaving the DOM. There's another set of classes for that, but we'll get to those later. Adding a fade effect is simple. First, we have to make the element look invisible. We can use the opacity property and set it to 0. The opacity property will allow us to manipulate the opaqueness of an element. That's all we'll need to do for the initial phase. Next, we'll define the fade enter active class. The enter active class is what's added for the entirety of the animation. This class is where we'll want to add the transition rules. We'll add the transition property with a value of all 0.25s linear. We won't bother with adding anything else. This property will create the fade effect we're seeking. We don't need to add the opacity property again because the default value for the opacity property is 1. 1 representing a fully opaque element. Since the fade enter class is removed after one frame, the browser's default CSS will get applied to the element. The opacity will transition from fully transparent to fully opaque. Let's give this a whirl. We'll refresh the page once more. Then we'll press the button again. As we press it, the element fades into view, which is what we wanted. However, it doesn't fade out. We're currently animating the element if it's entering the document. We haven't dealt with it when leaving the document. We'll have to add a different set of classes for when it's leaving. Vue will provide you with 3 classes. Instead of the keyword being enter, it's now leave. The leave from class is added during the first frame of the animation. The leave to class is added during the last frame of the animation. Lastly, the leave active class is added during the entire animation, including the first and last frames. Once the animation is finished playing, the element is removed from the document. Adding these classes is pretty easy. We've already taken the first step to using them. The transition component will add the leave classes for you. It handles both entering and leaving transitions. The value in the name property will apply to leave classes. We can move right along to adding the styles. We'll add the selector fade leave in the style block. We'll set the transition to all .25s linear, same as above. In addition, we'll set the opacity to 0. We won't have to worry about the initial state of the element because most elements will have an opacity of 1 from the beginning. We need to take care of fading it out, which is what these 2 lines will accomplish. Let's refresh the page one more time and toggle the element. Both animations will work without a problem. This is the basics of using CSS transitions with Vue. There's one important point I want to highlight. It's not required to use every class available to you. Keep it simple and carefully think about what you're trying to accomplish. The classes are pretty clear, so you shouldn't have any problems with adding animation with CSS transitions. We'll leave it at that. I'll see you in the next one. In this lecture, we're going to learn how to configure transitions. There are various things we can change about transitions to get the desired behavior. If you look at our transitions, you'll notice that we didn't tell Vue how long each animation should play. Vue is capable of looking at the styles applied to the elements it's transitioning. In the styles, we set the duration of the component. Vue will use the duration you set in your CSS. It'll automatically pick up how long the transition will be. We don't have to worry about telling Vue when to add or remove the element. It'll take care of detecting when to add or remove elements appropriately. That's very convenient because it allows us to focus more on the animation rather than having to tell Vue everything. It is possible to set the duration explicitly by setting the duration property on the transition component. The value for the duration must be in milliseconds. Vue will prioritize the duration property over the duration in the CSS if it's defined on the component. We aren't going to set a duration, so we'll remove this property on the component. We're not limited using the vIf directive. Animations can be applied to elements using the vShow directive. Inside the template, we'll change this from vIf to vShow. Hopping back on over to the page, you'll see that the animation works without a problem. You're free to use either set of directives. In the resource section of this lecture, I provide a link to the Vue documentation on Vue's animations and transitions. The transition component is very flexible. Feel free to read the documentation when you completed this section of the course. The last thing I want to show you is that we're not limited to one root element. Let's go back to the editor. Inside the app component, we're going to add another heading tag. This element will have the vElse directive applied to it. We'll need to update the first heading to use the vIf directive for this to work. This directive is considered valid because the conditionals work alongside each other. This way, you're not forced to use multiple transitions. You can keep everything inside one transition. Vue will handle the rest. However, we do need to assist Vue a bit. Vue will have a bit of trouble differentiating between two elements even though there's a conditional directive applied to them. We need to add the key attribute to both elements with a unique value. We'll set the first heading to main. The second heading will be set to secondary. We previously learned about the key attribute when working with loops. It's an attribute that helps Vue keep track of elements. Switching back to the page, we can toggle between both elements with the transition in effect. This effect is almost perfect. You may not be able to notice the problem since the animation is going pretty fast. Therefore, we're going to switch back to the app component to update the enter and leave animations to a duration of 3 seconds. Switching back on over to the browser, you'll see that after pressing the button, the second heading animates in first. Afterward, the main heading animates out. After the main heading animates out, the secondary heading snaps to the top. This animation is great if that's the kind of animation you're looking for. If not, we may want to reverse this. You may want the element currently active to animate out first, and then the second element to animate in. By default, Vue will animate the second element in and animate the first element out. You can reverse this by setting the mode. Let's go back to the editor. On the transition component, we'll apply an attribute called mode set to out-in. This property will do what we want. The mode determines the order of the animation. By default, the value will be in-out, which means any elements that are entering the document will be animated first. It'll then proceed to animate elements that are leaving the document. By setting it to out-in, the reverse will happen. Elements that are leaving the document will be animated first, followed by elements that are entering the document. This value should give us the desired result. After refreshing the page, we should see the opposite of what was happening before. The element fades out and the other element fades in. We've made things look more consistent. That's great. This is the basics of using animations in Vue. In the next couple of lectures, we'll continue with animating in Vue with different techniques. CSS transitions is one way to animate an element in Vue. Vue supports CSS animations, which are a more advanced way to animate elements. They give you more control over your animations. This isn't a CSS course, so I won't be diving too deep into the CSS syntax. We're going to comment out the first transition we created. We don't want it to bother us when working on a new transition. We're going to create another transition using CSS animations. To get started, we're going to add a new transition component. We'll place it below the first transition component in the template block. Inside of it, we'll be adding another heading with a basic message. We're going to add the name property with a value of zoom. We'll want to toggle the animation like last time. Let's apply the VIF directive to the heading element. We'll use the flag property to toggle the animation. We're going to make a zoom animation. Before we work on the animation, I want to add some styles to space out the headings. Inside the style block, select the heading. We'll set the width to 400 pixels. The padding and margin will be set to 20 pixels. While we're here, we're going to shorten the fade animation to last 1 second. 3 seconds is way too long. Next, let's work on the animation itself. We're going to create a zooming animation. If the element is entering the page, then it should zoom in. If the element is leaving, then it should zoom out. This effect can be done with transitions, but I want to show you how animations would work with Vue. At the bottom of the style block, we'll add the animation using the keyframes keyword. We'll call the animation zoom in. We'll keep the animation simple by using the from and to states. We won't bother with percentages. Inside the from block, we'll use the transform property to create the zooming effect. A zooming effect can be created using the scale CSS function. We'll scale the element to 0, 0. This value will make the element look invisible. It's not really. It's just been shrunken down to a very small size. Then, inside the to block, we'll set the scale back to 1, 1. This property will set the size back to what it was originally. This animation will give us the zoom effect we want. The zoom in animation is taken care of. Now we need to create the zoom out animation. We're going to create a copy of the zoom in animation. The animations are the same except in reverse. We don't need to rewrite the whole thing. We'll change the name to zoom out. We'll then switch the from and to states to get the opposite effect of the zoom in animation. The animations are set. The next step is to use them when Vue adds the classes to our elements. We're going to be using the same set of classes Vue has provided before. It's the exact same thing. Since the from and to states are set inside the keyframe, we don't have to rewrite the animation. Therefore, we can add the animations to the zoom enter active and zoom leave active classes. To add the animations, we need to use the animation property and pass in the animation name. For the enter animation, this will be zoom in. We're going to make the animation duration 1 second long with a linear speed curve. The mode will be set to forwards. By setting the mode to forwards, CSS will leave the element as is once the animation is complete. We don't want the animation to reset the scale to 0. Once again, Vue will be able to detect how long the animation should play by checking the duration you pass in the CSS. It'll appropriately add or remove the elements based on this value. We'll add the same set of properties to the zoom leave active class except with the zoom out animation. Let's give things a test. Back inside the browser, the heading shouldn't appear. After pressing the button, you'll see it zoom in or out depending on the current value of the flag property. Vue is able to detect the length of animation. It's able to correctly add or remove the element after the animation is complete. Vue can work with both transitions or animations. It can even work with both at the same time. Let's see what that looks like. Along with zooming in and out, we'll add a fade animation to the heading. Back inside the editor, we'll apply the transition property to both classes. The duration will be 1 second long. We'll set the opacity to 0 in the zoom leave and zoom enter classes. We won't be setting the opacity to 1 because that's the default value anyway. With that set, let's refresh the page and try pressing the button. The zoom and fade animations are being applied to the heading. This transition works fine, but there may be one problem you will run across when using both transitions and animations. If we look back at the code, you'll notice that both types of animations have the same duration, 1 second. What if we had two completely different durations? Update the transition to 2 seconds. By default, Vue will use the duration with the longest time. If possible, you want the duration in both properties to match. If necessary, Vue allows you to decide which duration to use. Inside the template block, we can add the type attribute to the transition component. The value for this can be either animation or transition. The value you pass in will tell Vue which duration it will use. Let's set this to animation. Since the animation is 1 second long, Vue will play the animation for 1 second. If other animations are playing on the same element, they won't finish if they play longer than 1 second. This is important to know if you plan on using a combination of CSS transitions and animations. We'll test this in one moment. There's one last thing I want to show you. Sometimes you may want to play the animation when the page loads. For example, in the data object, let's say I set the flag data property to true. This will mean that the element should appear on the page. However, if I were to switch back over the browser and refresh, you'll notice that the animations don't play. Instead, the elements just appear. It works, but it would be nice if the animation could play. We can override the default behavior by adding a property to the transition component called appear. Back in the editor, we'll add the appear property to the transition component. Switching back to the browser, the animation plays on the initial load. This animation is exactly what we wanted. The animation will play for 1 second. The zoom effect is what will last for 1 second while the fade effect lasts for 2 seconds. However, we never see the fade animation complete because the transition component is using the duration from the animation CSS property. We're finished reviewing CSS animations. You're free to use transitions, animations, or both. It's all preference. You have a variety of options at your disposal. CSS is usually the way to go when it comes to animating elements. It's the simplest way of adding animations. At times, you may need more control over the animation. In that case, controlling an animation with JavaScript might be what you need. Vue allows you to animate your elements with JavaScript. It doesn't take much work to get started. Vue will provide you with 3 hooks to use for both entering and leaving animations. The entering animations are used for when the element is being inserted into the DOM. There's the before enter hook, which is triggered before the animation starts. This hook allows you to prepare for anything you might need. Then, there's the enter hook, which is where you would perform the animation itself. This hook is where most of your code will be written. Lastly, there's the after enter hook, which is called when the animation is finished. This allows you to do cleanup if necessary. The leaving animations are used for when an element is being removed from the DOM. You have the before leave hook, which is triggered before the animation starts. The leave hook is where you would perform the animation. Lastly, the after leave hook is used after the animation is complete. Let's explore how to create animations with JavaScript. We'll work in the app components again. I recommend commenting out the transition component we currently have in the document. We don't want it to bother us when working on JavaScript animations. First things first, we need to use the transition component. We'll add it below the other transitions. Inside this component, we'll add the usual heading with the flag conditional check. We want to animate the transition. This time we'll want to do it purely with JavaScript. We can use hooks to handle the animation with JavaScript. They can be added by adding event listeners to the transition component. Let's add those in quickly. To recap, the events are called before enter, enter, after enter, before leave, leave, and after leave. We can run some functions whenever these events are emitted. We're going to pass in some functions for each event. We'll receive an error because the functions are undefined. We'll add them soon enough. The events I'm showing you are the ones we'll primarily be working with. There are two additional events I didn't cover. They are called the canceled events. It is possible to cancel an animation. Similar to the enter and leave events, you can listen for when an animation is canceled. We'll listen for those events which are the enter canceled and leave canceled events. These events are canceled whenever their respective animations are canceled. Not often used, but they are available if you need them. We're going to remove them because we're not going to look at canceling animations at the moment. Let's define the functions that will run when the animation starts for both phases. Inside the component object, we'll define the methods property. Next, we're going to define each function inside the methods object. The function names should match the names you passed in the events inside the transition component. We will have a total of 6 functions. Each function is passed in an object called element. The element argument contains information about the element that is currently being animated. You have complete freedom to change any of the properties on this object. You'll need it if you want to apply your own animations. We'll accept this inside each function. There is one more argument we can add. The parameter I'm about to introduce can only be used in 2 of the 6 functions. They would be the enter and leave functions. Both functions must accept in the done argument. The done argument we're being passed in is a function. You're meant to perform the animation in both functions, but Vue won't know when your animation is complete. The done function is a callback function that will tell Vue that the animation is finished playing. After this function has been called, Vue will proceed with adding or removing the element. You must call this function, or else Vue won't be able to do its job properly. We're going to call this function in both hooks. Our other functions are empty. Let's log a message in each of them with the element parameter. These long statements will let us know when the functions run. Switching over to the browser, we will see the heading appear since the flag property is set to true. If we take a look at the console, nothing will appear. If I press the button, the heading will be removed. The leave hooks are running in the order you would expect them to. First is the before leave hook, followed by the leave hook, and lastly, we have the after leave hook. Pressing the button once more will trigger the enter events. Once again, they're in the proper order. First is the before enter hook, followed by the enter hook, and lastly, we have the after enter hook. Currently, we're not animating anything. Let's start creating some animations in the next lecture. In this lecture, we're going to start writing an animation. The animation we're going to go for is a zoom animation. If the element is entering the document, it'll zoom into place. If the element is leaving the document, it'll zoom out. JavaScript is more than capable of handling this sort of animation efficiently. There's a myth that JavaScript is slower than CSS animations. That's not entirely true. There's an API called Web Animations. It's a new API that allows us to perform animations efficiently. It's even more efficient than CSS. It's a newer API that's unrelated to Vue. However, we can use this API with Vue. In the resource section of this lecture, I provide a link to the Web Animation API. It's still a fairly new API. I don't expect many of you to be aware of it. This will be a great time to get started with the API. Let's use it with Vue. We'll start with the enter animation. Switch back to the editor. Search for the enter function. The first step to using the Web Animation API is to select an element. An animation can only be played on an element. This requires us to make a selection. Typically, we would use the query selector or getElementById functions to select an element. We don't need to do that since the hook functions are provided with the element. We'll call the animate function on the element object. There's one thing I want to be clear about the element object. The element object we're working with is a normal DOM object. We have full access to the element's properties and methods. The animate function exists only on DOM objects, so it's not specific to Vue. The animate function will animate the element it's being called on. It has two arguments. The first argument is an array of properties to animate. The enter event runs whenever an element is inserted into the document. The properties we're going to animate will zoom the elements in. In the array, we're going to add two objects. Each object can be filled with CSS properties we'd like to add to the element. JavaScript will take care of transitioning between the properties. It'll apply the properties in the first object to the element. It'll then apply the properties in the second object. If we want, we can add as many objects to the array as we'd like. There's no limit. We're going to keep the animation simple. We'll have two objects, one for initial properties of the element, another for the properties the element should have when the animation is over. In the first object, we'll add the transform property. Its value will be the following: scale 3D 0, 0, 0. The scale 3D function will change the scale of the element. That'll make it look really small. We're attempting to make a zoom in animations. It makes sense for the element to be small. We want the element to grow in size. That's what we'll handle next. In the second object, we'll leave it empty. We're finished with the animation. The default scale for an element is 100%. We don't need to scale it back to its original size. The browser will assume we want the element to be its original size. The animate function will set the initial state of the element using the properties we have in the first object. It'll slowly transition the element's CSS properties from the first object to the second object. There's a second argument we can pass onto the animate function. It's an object of settings. This will allow us to change how the animation behaves from the duration to iterability. We're going to set the duration property to 1000. The duration will tell the browser how long to play the animation. The duration must be in milliseconds. The animation we're creating will last for 1 second. We're not going to configure the animation further. This will give us the effect we're looking for. The next step is to tell Vue when the animation is complete. As far as Vue knows, the animation can be playing forever. We can tell Vue the animation is finished by using the done function. However, we don't want to call it until the animation is complete. The animate function will return an object with events we can listen for. Let's assign the animate function to a variable called animation. Then, below it, we'll set the onFinish function to an arrow function. The onFinish event gets emitted when the animation is finished. The value for this must be a function that'll be called when the animation is complete. Inside this function, we'll call the done function to let Vue know we're finished. That'll do it for the enter animation. Let's work on the leave animation. It's going to be the same code. We can copy and paste the code from the enter method to the leave method like so. There's one modification we'll need to make to get the opposite effect. We'll reverse the order of the objects in the array for the animate function. Alright, let's give things a test. Refresh the browser and try pressing the button. The heading will zoom in and out based on the flag property. This animation works great, but we can further optimize it. Vue prefers that you use CSS animations over JavaScript animations. Because of this, Vue will check if you have a CSS animation for the transition. If you don't, it will use your JavaScript animation. Because of this, your animation takes up more resources than it has to. We can tell Vue directly we don't have a CSS animation. Go back to the editor. Inside the transition component with the JavaScript animation, we can bind a property called CSS. We'll set it to false. This property will instruct Vue not to check for a CSS animation. It'll skip right onto using the JavaScript animation. A very simple way to make your animations more efficient and faster. Aside from that, you should be good to go. That's how you can use JavaScript animations in your application. In this lecture, we're going to learn how to use CSS and JavaScript transitions together. We're not forced to use one or the other. You do have the option of using both CSS classes and JavaScript hooks to perform different jobs. For example, you may use them for performing background tasks while the animation is handled with CSS. That's definitely a good way to use both CSS and JavaScript together. In the app component file, we disabled CSS by setting the CSS property to false. By setting it to false, Vue will not add the CSS classes to the elements entering or leaving the document. Vue will ultimately rely on JavaScript hooks to handle the transition. The default value for this property is true. This value allows for both CSS classes and JavaScript hooks to be used. Let's change this to true. Currently, we're not using CSS to transition the elements. On the other hand, we're using JavaScript to create a growing effect. As I mentioned earlier, it's much more efficient to use CSS to handle animations. When you're using both CSS and JavaScript, Vue will use the CSS duration times to set the length of the transition. The done function provided by the hooks is optional. If you don't call the done function, that's perfectly fine. Vue will still know when the transition is complete. Since we're going to allow CSS to handle the animation, we'll clean up the hook functions we created in the previous lecture. In both the enter and leave functions, we're going to comment out the code that creates the JavaScript transition. It doesn't make sense to have two different animations that could potentially cancel each other out. We're going to remove the done parameter from the enter and leave functions. We must remove it. Otherwise, Vue will assume you want to use JavaScript to determine when the transitions are complete. By omitting this parameter, Vue will use the duration in the CSS to know how long the transition lasts. We're leaving behind the log statements. One last thing, we'll add the name property to the transition component. We'll reuse the fade animation we created in CSS. Set this to fade. After making those changes, switch back to the browser with the console opened. Trigger the animations by pressing the button. The elements will transition with the CSS classes. In the console, the hook functions are still logging the same messages. Despite not calling the done function, Vue will know when to call the next hook and when to start the next animation. This is because we're not accepting the done argument. If it's not present in the functions we defined, Vue will use the CSS durations to determine when the animations are complete. This is great because it gives us a whole lot more flexibility. If you want to send a request, update the state, or perform some other asynchronous task, you can do so without worrying about if the transition ends. This approach is how I recommend you use JavaScript hooks. Leave the animation to CSS. We've gone over the different ways to animate an element. You can use either CSS or JavaScript. You can even use both if need be. Vue is very flexible. It's one of the main reasons why developers love the framework so much. You can accomplish the same thing in different ways. It's entirely up to you. Although we've learned the different ways to animate an element, we haven't gone over how to animate a list. So far, we've been animating a single item or a group of items under a conditional directive. What if you wanted to animate a list? You may want to remove things from a list and add things to a list. That's simple enough to do. You already have the knowledge to accomplish something like that. The moment you add animations into the mix, things can get tricky. We can't use the transition component to animate lists. The transition component only works with single elements. If you want to animate a list of items, you'll need to use a different component. I'll talk about that special component in a moment, but first, let's create a list. Inside the app component, we're going to create a new data property. We'll call it numbers. It'll be assigned to an array. We'll put the numbers 1, 2, 3, 4, 5. We're going to output this list of numbers. You don't have to use numbers. You can use any example you can think of for a list. I'm trying to keep it as simple as possible. Let's output the list of numbers. Scrolling up to the template block, we're going to comment out the transition component we created in the previous lecture. We don't want it to get in our way. Next, at the bottom of the template block, we'll create an unordered list element. We'll apply the v_for directive to the list item element. The expression will be number in numbers. The alias, number, will represent the value in the current iteration. We'll output the number on each iteration. Inside the element, we'll add an expression for the number alias. We'll also bind the key attribute to the number as well. Remember that the key attribute will help Vue identify which item in the array belongs to which element. It'll help us from running into strange bugs when making changes to the list. Before we continue, we're going to change the font size of the list to 22 pixels inside the style block. It'll make things easier to view. We're also going to set the pointer to cursor. We're going to make it so that the user can delete list items by clicking on them. Setting the cursor to a different icon will indicate that they can do so. This is more of a visual decision rather than a view-related one. The next steps are to add an item to the list and remove them when clicked. We'll start with adding numbers. Above the unordered list element, we're going to add a button. We'll listen for a click event on the button. If a click is registered, we'll call the function addItem. This function doesn't exist. We'll have to define it in the methods object of the component. We're going to need two things. First, we need the number to add. Secondly, we're going to need to figure out where to insert the number in the array. We could add it to the end of the list and call it a day. But let's make it challenging by randomizing where the number will be inserted. We'll start by calculating the number to add to the list. We're going to create a variable called num. We'll set it to math.floor, math.random, asterisk 100 plus 1. This expression will generate a random number between 1 and 100. Next, we'll calculate an index. We'll create a variable called index. We'll set it to math.floor, math.random, asterisk this.numbers.length. This algorithm will randomly select an index inside the array. We'll insert the number to whatever this results in. From here, we can run the splice function on the numbers data property. The splice function can remove values, but we don't want to do that. It's possible to insert values into an array with it. We'll set the first two arguments to index and 0, respectively. The third parameter will be the value we'd like to insert, which will be num. This function will push a number into the array. Let's work on removing the value. In order to remove the value, we'll need the index. Without the index, we won't know which number to remove. Therefore, we'll need to update the expression inside the v_for directive. We'll wrap the first half of this expression in parentheses. This additional syntax is necessary if we want to extract the index. The alias for the index will be index. I know it's been a while since we've had to do this, so let me give you a refresher. You can grab the index of the current iteration by defining it inside these parentheses. The second value is the alias name for the index. We're plainly naming it index. With the index in hand, we can add a click event listener to the list item. We'll call the function removeItem and pass in the index. Next, we'll need to define the function inside the methods object. Inside the function, we'll call the splice function. This time we'll pass in the index we're provided. The number of items to remove is 1. We aren't going to use the third parameter because we aren't trying to add anything to the array. This function should remove whatever item was clicked on in the list. We're finished with writing the function. Let's give things a test. On the page, we will continue to see the same 5 numbers. Clicking on the button will result in a new number added to the list. The number should be random. It will appear in a random location. Adding numbers works fine. Let's test the removal of the numbers. Clicking on any number will result in its removal. This is great. It works as we wanted it to. Now we can begin animating them. I want to animate numbers fading in or out, depending on the action. Back inside the template, we're going to wrap the list tag with a transition group component. You can't use the transition component because it doesn't work with list items. The transition group component is specifically for animating items in a loop. There are not many differences between transition and transition group components. It has the same properties and hooks. It has the enter and leave hooks. You can apply the same set of CSS and JavaScript animations if you wish. One important difference is that you can't set the mode property. You can't set the mode to out-in or in-out. Other than that, we should be fine. We're going to reuse an animation we've defined already. We're going to set the name attribute to fade. The animation we're using will fade the elements in or out based on the action being performed. We don't have to worry about creating the CSS styles because we've already done that in an earlier lecture. Time for another test. We'll refresh the page, which will give us a fresh list. If we were to click on the button, then a new number is generated. It's added onto the list in a random location. The best part is that it animates in. It properly fades in like we want it to. We can even click on any of the list items. The correct item will fade away before being removed. We've got a working solution, but it isn't perfect. We'll discuss the problem in the next lecture. In this lecture, we're going to fix a problem in our animated list. This transition is almost perfect. One thing you'll notice is that the list items jump. If I add a list item, any numbers below that number will jump down to make room. If I were to remove an item, the numbers above it jump up to compensate for the space. The snappiness isn't appealing at all. Vue will not take care of it for us. We're the ones responsible for handling how sibling elements should move. Go back to the editor. Vue will add a class to elements that are being moved over. It's called the Move class. Just like the other CSS classes, Vue will prepend the name of the transition to the generated class name. In this instance, the class name would be FadeMove. Using this class, we can animate the other items. We're going to define the class in the style block below the other Fade classes. Vue applies the Transform CSS property to the elements that are moving. It'll take care of updating the Transform CSS property. Therefore, we don't need to do anything ourselves. We don't see the effect of Vue transforming the element because the transition property is not applied to it. The transition property is what will make the movement look smoother. We'll define the transition property with a duration of 1 second with a linear motion. The transform property is automatically applied to the list items that get moved. We're following it up by telling the browser it should smoothly transition them rather than jumping immediately. With that set, let's give things a test again. We'll try adding items to the list. As we add them in, not only does the element fade in, the elements below it slide down smoothly. This is because the fade move class is being applied to the other elements where we apply the transition property. This doesn't solve all our problems. If I were to remove an element, you'd see that Vue doesn't properly animate the items moving back up. Why is that? This is because the element doesn't have to move during the animation technically. Keep in mind that two things are happening when we add or remove numbers. There's the addition or removal of an element. Then there's the animation itself. When a number is added, Vue will add a list item with that number. That element will occupy space. Therefore, any elements taking up that space have to be moved. During that process, Vue will animate the element by fading it in. We're not increasing its size or changing its height. It already takes up that space. When we remove an element, the opposite happens. The animation plays first, and then the element gets removed. Even though the element is fading away, it still occupies that space. As a result, the other elements don't have to move. Their transform property doesn't have to change. The move class gets applied during the animation. Once the animation is over, the element gets removed, and the move class is also removed. Therefore, it never gets the chance to animate the other list items. How do we get the move class to animate the elements if the item being removed still holds its space? Well, there are a number of ways, but the simplest is by using absolute positioning. Switching back to the editor, we're going to set the position to absolute inside the fade leave active class. By using absolute positioning, the item fading away will give up its space, forcing the other elements to move up. After making this change, let's test if this works. If I were to click on any list item, the items below it would smoothly move up, taking its space. This is fantastic. We've removed the snapping motion we had before. This makes things smoother and cleaner. We're finished with animating the list. If you're not someone who's very good at animations or just want to save time, you may resort to using a third-party animation library. In the resource section of this lecture, I provide a link to a library called animate.css. It's a popular library that comes with predefined animations. They can be used in any application. It's as simple as loading it in and then applying the classes to your elements. However, we do face a problem. The classes generated by Vue don't match the class names in the library. If they don't match, we won't be able to play the animation. We can override this behavior by explicitly setting the class names. Let's try that out. First things first, we'll want to load the animate library into our app. In the resource section of this lecture, I provide a link to a CDN. We're going to load animate through an external source. Copy the link provided on the page. Make sure you're copying the link with the minified version. After copying the link, open the index.html file in our project. In the head section, with the other style sheets, link the animate style sheet. Next, open the app component file. We're going to apply the animations to the transition group component we wrapped around the list. We can begin to use the animations that come with the animate library. To completely override the names, we can use the following properties. Enter from class. Enter active class. Enter to class. Leave from class. Leave active class. Leave2 class. Each class can be explicitly set by defining these properties on the transition group component. Vue will not add any additional phrases or names to your class names. You have complete control over the class name. Keep in mind, you can apply these same properties to the transition component. They behave the exact same way. The animate library uses CSS animations. We don't need to set a class for every property. The animate library will take care of setting the CSS properties from beginning to end. That means we can just set the active classes to get the animation working. In fact, I want to highlight that if you were to leave the class name properties empty, then Vue will throw an error at you. We're going to remove every property except for the enter active class and leave active class classes. The animate library comes with an abundance of animations. You're free to use any you'd like. For the enter transition, we're going to use the following: animate, animated, animates, flip in X. For the leave transition, we'll use the following classes: animate, animated, animate, flip out X. The animated class will set some default stylings for the animations. It's required whenever you want to use any of the animations from the animate library. Afterward, we can add in any of the animations. A list can be found on the documentation page I linked to earlier. In this example, we're using the flip animation. All animation classes start with the word animate followed by 2 underscores. Before we give the animations a test, there are 2 things we'll want to adjust. First, we need to add absolute positioning to the class that's applied to the element when it's leaving the document. Otherwise, the other elements will not animate into place like we want them to. Secondly, I want to show you how to override the duration. The default duration is 1 second. In the style block, add the animate flip out X selector. Set the position property to absolute. It's important we're applying this to the leave transition. The transition for when an element is entering the document doesn't need this. Next, let's look at modifying the duration. The duration of the animation by default is 1 second. The animate library sets this duration. We can override the duration by changing the CSS property. Let's look at an example. In the style block, add the animate animated class. Set the animation duration property to 1.5 seconds. Both the browser and Vue will use the duration you defined in the style block. It'll take precedence. Go ahead with testing the transition. The form will flip in and out like we wanted. The other elements are moving smoothly when an element is entering or leaving the page. By defining the class properties on the component, we're able to use any animation library we want, even if it has a different set of class names. Custom names can only be defined on a local level. Unfortunately, there isn't a way to override the names on a global level. Keep that in mind in case you want to go heavy on the animations.